There's something behind the sun that no one was prepared to see. An object moving faster than anything we've ever recorded has begun emitting a jet of gas, pointed directly at the sun, not away from it. They call it 3I Atlas, the third confirmed interstellar object to ever enter our solar system. NASA says it's just a comet, but comets don't do this. This thing is ejecting nickel, a refined metal compound never before observed in nature, while releasing cyanide and carbon dioxide toward the sun in a perfect, continuous stream. And just days before it disappeared behind the solar disk, the Mars Reconnaissance Orbiter captured images that, according to scientists, still haven't been released. Now, as 3I Atlas reaches its closest point to the sun, no one on Earth can see what it's doing. No telescope, no camera, just silence, and a Harvard astrophysicist warning: if you want to take a vacation, take it before October 29, because who knows what will happen. So, what does 3I Atlas want with the sun? Is it burning away, refueling, or performing something we were never meant to witness? If you find this as fascinating and unsettling as I do, tell me in the comments where you're watching from, what time it is there, and whether you think we're seeing the whole picture. Chapter 1. The Visitor. Let's start with what we know for certain. 3I Atlas was discovered on July 1st, 2025, by an automated survey telescope in Chile. It was initially just a designation, a 11PL3Z, a fuzzy dot moving against the background stars at an unusual speed. Within 48 hours, orbital calculations confirmed what astronomers had suspected: this object wasn't from our solar system. It came from the direction of Sagittarius, from somewhere near the galactic core, and it was traveling at 58 kilometers per second relative to the sun. That's more than twice the escape velocity needed to leave the solar system entirely, which meant it couldn't have originated here. It had to have come from somewhere else. Another star system, another world. The third interstellar visitor, after Oumuamua in 2017 and 2I Borisov in 2019. But 3I Atlas was different from its predecessors in ways that immediately captured attention. Oumuamua had been small, dark, and enigmatic, possibly a rock, possibly something else. 2I Borisov had been a clear comet, behaving exactly as expected, a cosmic tourist, passing through without incident. 3I Atlas fell somewhere in between. It had a coma, a cloud of gas and dust, typical of comets. Early observations showed it was releasing carbon dioxide, cyanide, traces of water vapor, all normal cometary stuff, but the proportions were wrong. The CO2-to-water ratio was 8:1, among the highest ever recorded. Most comets are water-rich. This one wasn't. And then there was its trajectory. Objects from interstellar space can approach our solar system from any direction, at any angle. There's no reason they should care about our geometry, but 3I Atlas arrived on a path inclined just 4.89 degrees from the ecliptic plane, almost perfectly flat relative to Earth's orbit. The statistical probability of that alignment, given a random trajectory, about 0.2%, 1 in 500, not impossible, but rare enough to notice. And it wasn't just the ecliptic alignment. The object's path brought it unusually close to multiple planets. Mars, Venus, Jupiter, close encounters that, statistically, should occur together in roughly 1 out of every 20,000 random trajectories. Harvard astrophysicist Avi Loeb calculated those probabilities carefully. He published papers pointing out the anomalies. He suggested cautiously, academically, that the trajectory might not be random, that it might be designed, that 3I Atlas could be something other than a natural comet. The scientific community, predictably, pushed back hard. NASA's Tom Statler called it absolute nonsense. Other astronomers dismissed Loeb's claims as attention-seeking, pointing out that comets are inherently messy, unpredictable objects that often display unusual properties. And they were right, in a sense. 3I Atlas did look like a comet. It did comet things. It had a coma, it outgassed, it developed a faint tail by late August, all textbook behavior. But there were still the anomalies, small things that didn't quite fit. Things that, individually, could be explained away, but together painted a picture of something not entirely understood. The size estimates kept changing. First 20 kilometers across, massive for an interstellar visitor, then revised down to 10 kilometers, then to 5.6 kilometers based on Hubble data. But calculations of its mass, derived from tracking how the object resisted being pushed around by its own gas jets, suggested it weighed at least 33 billion tons. That's heavy. Too heavy for a 5-kilometer chunk of ice and rock, unless it isn't solid, unless there's empty space inside. And then there was the timing. 3. Atlas would reach its closest point to the Sun, perihelion, on October 29, 2025. On that exact date, Earth would be on the opposite side of the Sun. Every telescope on our planet would have the Sun directly between us and the comet. Solar conjunction. Complete observational blackout during what should be the object's most active and revealing moment. Loeb pointed out that this would be the optimal time to perform what's called a reverse solar Oberth maneuver, using the Sun's gravity and a well-timed thrust to break from interstellar speed and capture into a bound orbit around the Sun to stay instead of leaving. And if 3I Atlas wanted to make that maneuver without being observed, this would be the perfect window. October 29th, hidden from Earth's view, doing something we couldn't see. Which brings us back to Mars. Chapter 2. The Martian window. While Earth would be blind during perihelion, Mars would have a clear view. On October 3rd, 2025, 3I Atlas passed within 29 million kilometers of the red planet. In astronomical terms, that's practically a near miss. Close enough that the 7 spacecraft orbiting Mars could turn their cameras and spectrometers toward the visitor and capture images at resolutions Earth-based telescopes could never match. This was the opportunity, the one chance to see 3I Atlas up close before it disappeared behind the Sun. NASA's Mars Reconnaissance Orbiter has a camera called HiRISE, the High-Resolution Imaging Science Experiment. It's designed to photograph the Martian surface from orbit with enough detail to see individual boulders and rover tracks. When pointed at 3I Atlas from 29 million kilometers away, it should have been able to resolve features down to about 30 kilometers across. Not enough to see surface details on a 5-kilometer nucleus, but enough to separate the solid core from the surrounding coma of gas and dust. Enough to get a real size estimate, enough to see if there was anything unusual about its shape or structure. ESA's ExoMars Trace Gas Orbiter was positioned to do spectroscopy, analyzing the light reflected and emitted by the comet to determine its composition with unprecedented precision. The UAE's Hope Orbiter, China's Tianwen-1, all had instruments capable of contributing data. This was a coordinated international observation campaign, planned months in advance. Every space agency involved knew the stakes, and then the U.S. government shut down. On October 1st, just 2 days before the Mars flyby, over 15,000 NASA employees were furloughed. The agency's website stopped updating. Public communications ceased. It was, according to official statements, bureaucratic paralysis at the worst possible moment. But here's what doesn't add up. The ESA is a European agency completely unaffected by American politics. They released their images on October 7th, 4 days after the flyby. But what they showed was disappointing. Fuzzy white dots moving against a star field. No detail. No structure. Images that, frankly, told us nothing we didn't already know. The explanation was technical. The cameras were designed to photograph Mars from a few hundred kilometers away. Not a faint object, 10 of millions of kilometers distant. The comet was 10,000 to 100,000 times fainter than their usual targets. They did their best with inadequate equipment. Fair enough. But NASA's HiRISE camera was built for this. Its angular resolution at 29 million kilometers would have been more than 10 times better than anything the ESA achieved. If any instrument could reveal 3I Atlas's true nature, it was HiRISE. And HiRISE was operational. The Mars Reconnaissance Orbiter continued its normal functions throughout the government shutdown. Other rovers and orbiters kept transmitting data. The Perseverance rover, for instance, uploaded raw images to public servers throughout the entire period. So why were the high-rise images of 3i Atlas never released? The government shutdown excuse started to feel less like an explanation and more like a convenient cover, especially when you realize that China's Tianwen-1 also went mysteriously silent about its observations. The UAE's Hope orbiter, which should have had excellent spectroscopic data, released nothing. Multiple sovereign governments with completely separate bureaucracies and priorities, all simultaneously unable or unwilling to share their best data on the most scientifically significant object to visit our solar system in years. The pattern was hard to ignore, and then amateur astronomers started finding things. Chapter 3. The Amateur Evidence, 2030-28-0. On October 3rd, the same day as the Mars flyby, a Portuguese amateur astronomer, operating under the username Dobsonian Power, uploaded an image to Reddit that immediately went viral. He'd used nothing more than a solar telescope from his backyard equipment, not even designed for deep space observation, and some aggressive digital enhancement. What he captured was a fuzzy image of 3i Atlas, but within that fuzz, he claimed to see structure, dark geometric shapes, angular protrusions, something that didn't match the typical diffuse glow of a comet's coma. His caption was simple: "What on earth is it?" Within 6 hours, the image had been shared across every major astronomy forum, subreddit, and social media platform. The reaction split into two camps almost instantly. One group saw clear evidence of artificial structures, proof that 3i Atlas was not what mainstream science claimed it to be. The other group dismissed it as classic pareidolia, the human tendency to see patterns where none exist, amplified by inappropriate equipment and processing artifacts. The debunkers had solid technical arguments. Solar telescopes use specialized filters designed for observing the sun's extreme brightness, not faint deep space objects traveling at interstellar velocities. The equipment simply wasn't built for this kind of observation. Add aggressive digital enhancement to compensate for the inadequate setup, and you're essentially asking an algorithm to invent details that aren't really there. But here's where the story gets complicated. Dobsonian Power isn't some random internet conspiracy theorist with a cheap telescope and too much imagination. He's a respected amateur astronomer who's been sharing legitimate astrophotography work for over a decade. His YouTube channel features careful documentation of his equipment, his methods, his image processing workflows. This isn't someone trying to manufacture evidence for clicks. And when pressed on the anomalous structures in his 3i Atlas image, he didn't double down with wild claims. Instead, he acknowledged uncertainty. He promised to try again when the object became visible from Earth in early November, after passing behind the Sunday. His response was measured, scientific, appropriately cautious, which made the reaction to his image even more telling. Within 24 hours, multiple websites published articles specifically debunking his capture. Amateur telescope captures strange 3i Atlas image. Here's why it's not what it seems. The timing felt coordinated. The tone felt defensive, as if someone needed to quickly establish the narrative that nothing unusual had been photographed, that any apparent anomalies were merely technical artifacts before the image could gain too much traction. And then the enhancement wars began. Users across Reddit, Twitter, and various forums started downloading the original ESA images and running them through their own processing algorithms. Some used standard astronomical image stacking techniques. Others employed AI upscaling tools designed for enhancing low-resolution photos. A few went full chaos mode with machine learning models trained to reconstruct fine details from limited data. The results varied wildly. Some showed nothing but slightly sharper versions of the same fuzzy dot. Others revealed what appeared to be distinct geometric patterns, edges, structures that seemed too regular to be natural, ice and rock. The problem is that once you start aggressively processing an image, especially with AI tools, you're no longer looking at what's actually there. You're looking at what an algorithm thinks should be there based on its training data. If you train an AI on thousands of images of spacecraft and then ask it to enhance a blurry dot, it might very well invent spacecraft-like details because that's what it's learned to recognize. It's a scientific dead end wrapped in the illusion of clarity. But the proliferation of these enhanced images had an unintended effect. They muddied the water so thoroughly that distinguishing between legitimate amateur observations and outright fabrications became nearly impossible. Within 48 hours of the ESA photo release, there were dozens of supposedly enhanced versions circulating online. Some showed metallic surfaces, others depicted what looked like solar panels or antenna arrays. A few even included running lights and visible thrusters. Most were obviously fake digital art, created by people with too much time and too much Photoshop skill. But mixed in with the noise were a handful of images that felt different. More subtle, less sensational, images that showed just enough unusual regularity to make you wonder whether something real was being obscured by the flood of obvious hoaxes. And then, on October 4th, something else appeared. Chapter 4. The 4chan Leak. An anonymous user on 4chan's paranormal board posted what they claimed was insider information about 3i Atlas. The post was titled simply, ESA Data Leak. It began with a credential claim that was specific enough to sound legitimate, but vague enough to maintain anonymity. I am a doctoral researcher working with the European Space Agency with continuous access to the combined observational data of 3i Atlas. Internet leaks are a dime a dozen. Most are easily dismissed as creative fiction or outright trolling. But this one was different. The level of technical detail was unsettling. The poster didn't make wild claims about alien invasions or secret military operations. Instead, they laid out a series of specific observational anomalies that, if true, would fundamentally challenge our understanding of what 3i Atlas actually is. The first anomaly: chemical impossibility. According to the post, spectroscopic analysis showed 3i Atlas was releasing approximately 100 kilograms of nickel gas per second, but with almost no iron emission. In normal stellar and planetary chemistry, nickel and iron are inseparable twins. They form together in supernova explosions. They travel together through interstellar space, and they appear together in comets and asteroids. Finding abundant nickel with virtually no iron is like finding smoke without fire. It violates basic assumptions about how matter behaves in natural cosmic environments. The second anomaly: thermal contradiction. The object was releasing massive amounts of gas and dust, the characteristic signature of an active comet being heated by the sun. But infrared observations showed it remained cold, far colder than it should be, given its outgassing rate and proximity to solar radiation. The poster compared it to watching someone sweat profusely in a freezer. The physics don't match the observation. The third anomaly: trajectory precision. The post referenced what Avi Loeb had been saying publicly, that 3i Atlas arrived with an orbital inclination of just 4.89 degrees relative to Earth's ecliptic plane. But the 4chan poster added something Loeb didn't emphasize. The trajectory isn't just unusual. It's a perfect straight shot from the direction of the galactic core. No wobble, no deviation. No signs of gravitational perturbation from nearby stars during its millions or billions of years traveling through interstellar space, as if it was aimed. Then came the part that elevated this from interesting speculation to something darker. The poster claimed the object fit the profile of what they called a post-biological entity. Not a natural comet, not a conventional spacecraft, something in between. They described it as having a 3-phase particle engine with an estimated power output of 75 megawatts, continuously transmitting an active signal, and in their words, probing our solar system. The post concluded with a theoretical framework. The poster suggested 3i Atlas might be a macroscopic quantum object, specifically something called a cue ball. It's an exotic theoretical construct from particle physics, a type of non-topological soliton that could theoretically exist at scales far larger than subatomic particles. If stable, a cue ball could have properties that seem impossible under normal physics. It could be incredibly dense while appearing diffuse. It could absorb and redistribute energy instantaneously across its entire structure, explaining the thermal contradictions. It could even explain the nickel without iron problem if the cue ball's internal quantum state preferentially produces certain isotopes. Within 18 hours, The post had been screenshotted and shared across Reddit, Twitter, and dedicated UFO research forums. The conspiracy subreddit thread discussing it accumulated over 2,000 comments before moderators locked it for violating rules against unverified claims. But locking the thread didn't stop the conversation. It just moved it to other platforms, fragmenting into dozens of parallel discussions, each pulling the original post in different directions. Some focused on the chemical anomalies, others zeroed in on the cue ball hypothesis. A few started connecting it to earlier claims about 3I Atlas potentially being the source of the 1977 WOW signal. And here's where it gets interesting, because while the 4chan post was clearly speculative, mixing legitimate scientific concepts with wild theoretical physics, some of the claims were actually verifiable. The nickel without iron observation, for instance. That could be checked against published spectroscopic data, and when people started checking, they found something unexpected. The Very Large Telescope had published observations confirming the presence of nickel in 3I Atlas's coma on August 21st. The paper explicitly noted the unusual absence of iron, which typically accompanies nickel in cometary emissions. The 4chan poster had been right about that detail, which made people wonder what else they might be right about. Chapter 5. The Perseverance Anomaly. On October 4th, NASA's Perseverance rover, sitting in Jezero crater on the Martian surface, captured something in the night sky above. The image from its right navigation camera showed an elongated streak of light, roughly 4 times longer than it was wide. At first glance, it looked like a typical long-exposure capture of a moving object. Comets and asteroids often appear smeared in images when the camera tracks stars instead of the object itself. Standard stuff. Except the math didn't work out that way. When people started calculating the apparent size of the streak based on Perseverance's known camera specifications and the distance to 3I Atlas at the time, they arrived at a disturbing number, 50,000 kilometers long. That's not a comet nucleus. That's not even a comet with a tail. That's something else entirely. For comparison, Earth's diameter is less than 13,000 kilometers. If this streak represented the actual physical size of 3I Atlas, we were looking at an object nearly 4 times wider than our entire planet. Social media exploded with speculation. Was 3I Atlas actually a massive cylindrical craft? Had it been masking its true size and shape this whole time behind a diffuse cloud of gas and dust? The timing felt significant. This image emerged just 1 day after the Mars flyby, right when all the professional space agencies went mysteriously quiet. Some saw it as confirmation that something deeply anomalous had been photographed, something that couldn't be easily explained away. The speculation reached high enough that Representative Anna Paulina Luna, a member of Congress known for her interest in unexplained aerial phenomena, reached out directly to Avi Loeb for his analysis. Think about that for a moment. A sitting member of the United States House of Representatives felt compelled to contact a Harvard physicist about a photograph from Mars. That's not normal protocol. That suggests someone in official channels was concerned enough to want expert interpretation outside the usual NASA communication pipeline. Loeb's response was thorough and, on the surface, reassuring. He calculated that the Perseverance navcam has an angular resolution of 0.33 milliradians per pixel. At the distance of 3I Atlas, when the image was taken approximately 38 million kilometers, that translates to about 12,500 kilometers per pixel, the streak in the image spans roughly 4 pixels, which gives you that 50,000 kilometer length. But Loeb argued this was an artifact of composite imaging. The streak wasn't showing the actual size of 3I Atlas. It was showing the path the object traced across the Martian sky during a long integration time, likely around 10 minutes of stacked exposures. His reasoning was solid. Mars orbits the Sun at 24 kilometers per second. 3I Atlas was traveling at 67 kilometers per second relative to the Sun in the opposite direction, giving it a relative velocity of over 90 kilometers per second compared to Mars. Over 10 minutes, that's exactly 54,000 kilometers of travel, perfectly matching the observed streak length. The shape wasn't the object. It was the object's motion smeared across time. Case closed, right? The cylinder theory debunked by basic physics and careful math. Except Loeb included one sentence in his analysis that conspiracy theorists latched onto like a lifeline. He wrote, "If the navcam images represent single snapshots with an exposure time below 3.28 seconds, then the brightness and angular length of the observed source imply that it is not 3I Atlas. In that case, the source might be much closer to the camera, capable of being smeared into an elongated image with a smaller spatial size and a smaller speed. Wait, if these are single-frame captures, if Perseverance took a quick snapshot rather than a long exposure, then what it photographed wasn't 3I Atlas at all. It was something else. Something closer to Mars. Something near the rover. That qualifier opened a door that no amount of subsequent clarification could fully close. Because NASA hasn't confirmed whether the image is a composite or a single frame, they haven't released the metadata. They haven't provided the exposure time or the number of stacked images. The government shutdown excuse applies here too. No staff to process requests. No one available to confirm basic technical details about how the image was captured. And so the question hangs in the air, unanswered. What did Perseverance actually photograph on October 4th? Chapter 6, Building on Mars. The phrase appeared first in YouTube titles around October 7th. Just as the ESA was releasing their disappointing images from the Mars flyby. 3I Atlas is building something on Mars. Leaked images reveal what it's building on Mars. Mars rover exposed 3I Atlas cylindrical structure. The truth is alarming. The videos were clickbait, obviously, but they were also picking up on something real, a pattern of speculation that had been building across multiple platforms, fed by the absence of official data and the presence of numerous unexplained details. The theory, in its most coherent form, went something like this. 3I Atlas isn't just passing through. Its trajectory brought it unusually close to Mars, closer than any other interstellar object has come to any planet in recorded history. That proximity wasn't random, it was purposeful, and during that close approach, while hidden from Earth's view, the object either deployed something toward Mars or interacted with something already there. The evidence cited included the Perseverance streak that might show an object closer to Mars than 3I Atlas itself, amateur observations showing unusual structures within the comet's coma, the coordinated silence from multiple space agencies. Earlier, anomalies photographed by Mars rovers that had been dismissed as rocks or imaging artifacts, but which, when re-examined, showed geometric regularity. And then there were the towers. In 2015, a Mars rover had photographed something in the distance that looked like a vertical structure rising from the Martian surface. NASA identified it as a rock formation, likely caused by wind erosion. The resemblance to an artificial structure was just pareidolia. But in the Terra Meridiani region, amateur analysts poring over public Mars imagery claim to have found multiple vertical structures, some appearing to be several kilometers tall. When those images were enhanced and measurements attempted, the structures seemed to maintain consistent spacing, as if arranged in a pattern. Again, NASA's explanation was geological. Wind-carved features, layered rock formations, standing at unusual angles. The Martian surface is full of strange geology that can look artificial under the right lighting conditions. But now, with 3I Atlas passing so close to Mars, those old anomalies were being revisited. Were they really just rocks? Or had something been building on Mars for a long time, and 3I Atlas's arrival was connected to that construction somehow? The speculation reached a fever pitch when users started claiming they had downloaded images before NASA shut down access to certain databases, images that supposedly showed construction equipment, geometric foundations, mechanical structures rising from the Martian regolith. Most of these images were fake, digital art, photoshopped composites, but they spread anyway, shared breathlessly across conspiracy forums and UFO research groups, each iteration adding new layers of interpretation and analysis. The narrative that emerged was surprisingly coherent. 3I Atlas is not a natural comet. It's a carrier, a mothership of some kind. It approaches Mars, not Earth. Notice, but Mars. And during its closest approach on October 3rd, it deploys something. A lander, construction equipment, seeds for some larger structure. That's why all the space agencies went silent. They saw it happen, they photographed it happening. And now they're trying to figure out what to do about it, what to tell the public, how to manage the revelation that we are not alone and that something is actively building infrastructure on the planet next door. Is any of this true? Almost certainly not. The evidence is thin, speculative, built on coincidences and imaging artifacts. Most of the leaked images are demonstrably fake. The scientific consensus remains that 3I-ATLAS is a natural interstellar comet exhibiting unusual but explainable properties. But the fact that this narrative exists at all tells us something important. It tells us that people don't trust the official story. They see the gaps, the missing data, the convenient shutdowns, the coordinated silence, and they fill those gaps with speculation. And in the absence of transparency, speculation grows wilder, more elaborate, more divorced from evidence-based reasoning. Which brings us to the real question underlying all of this. Why hasn't more data been released? Chapter 7. The Wow Connection. There's another layer to this story that makes the timing of 3I-Atlas's arrival feel even more uncanny. On August 15th, 1977, 48 years ago, Ohio State University's Big Ear radio telescope detected a 72-second burst of radio energy so unusual, so perfectly structured, that astronomer Jerry Ehman circled it on the printout and wrote one word in red pen. Wow. For nearly 5 decades, that signal has remained one of the greatest mysteries in the search for extraterrestrial intelligence. It came from the direction of Sagittarius, near the constellation's densest star fields. It was narrowband, focused at one specific frequency, and it has never repeated. Hundreds of follow-up observations, thousands of hours of listening time pointed at the same region of sky. Nothing. Just that one burst 48 years ago, and then eternal silence, until Avi Loeb ran the numbers on 3I-Atlas. He calculated where the object was on August 12th, 1977, just 3 days before the WOW signal was detected. The answer: approximately 600 astronomical units from Earth. Roughly 600 times the distance between Earth and the Sunday. But more importantly, he calculated what direction 3I-Atlas was coming from at that time. Right ascension, 19 hours 40 minutes. Declination, -19 degrees. The WOW signal came from right ascension, 19 hours 25 minutes. Declination, -27 degrees. The two directions are separated by approximately 9 degrees. In the vastness of space, with random objects coming from literally any possible direction, the probability of this alignment is about 0.6%. Not impossible, but deeply suspicious. Loeb didn't stop there. He asked the next logical question. If 3I-Atlas sent the WOW signal from 600 AU away, how powerful would the transmitter need to be? The math is straightforward. The detected intensity was between 54 and 212 Janskis across a 10 kHz bandwidth. At 600 AU distance, that corresponds to a transmitter output between 0.5 gigawatt and 2 gigawatts. For reference, a typical nuclear reactor on Earth produces about 1 gigawatt, so we're talking about nuclear power plant levels of energy, focused into a narrow radio beam. Not impossible for an advanced civilization. Actually quite reasonable if you're trying to send a detectable signal across interstellar distances without wasting energy on omnidirectional broadcasting. There's another detail that makes the connection harder to dismiss. The WOW signal was observed at a frequency of 1,420.4556 MHz, blue shifted by approximately 10 km per second toward Earth relative to the hydrogen line. That blue shift indicates the source was moving toward us. 3I-Atlas is currently approaching the Sun at about 60 kilometers per second. Loeb suggests that if this object has maneuvering capability, it could have been moving slower in 1977 then accelerated after detecting habitable zone planets in our solar system. A reconnaissance pulse. A radar scan, checking for signs of technological civilization before committing to a closer approach. Here's what makes this entire connection so frustrating. It would be trivially easy to check. Point a radio telescope at 3I Atlas. Listen at the hydrogen line frequency. If it's transmitting, we'll know within hours. If it's silent, the WOW signal connection is probably coincidental. Simple test, definitive answer. And yet, as Loeb noted in his latest blog post, not a single radio telescope has reported data on 3I Atlas. The Very Large Array hasn't looked. The Arecibo telescope is destroyed. The Green Bank telescope hasn't published observations. Even SETI, the organization literally dedicated to finding extraterrestrial signals, hasn't publicly announced any monitoring efforts. The silence from the radio astronomy community is deafening. Now, to be fair, there could be practical reasons for this. Radio telescope time is expensive and competitive. Most facilities book observations months in advance. The WOW signal connection might seem too tenuous to justify the resources. Or maybe they have looked, found nothing, and decided there was nothing to report. Or maybe they've looked and found something, and they're trying to figure out what it means before going public. We don't know, because they haven't told us. And in that silence, the speculation grows. If 3I Atlas is the source of the WOW signal, then it's been aware of us for at least 48 years. It's been watching, listening, moving slowly but deliberately toward our solar system. And now it's here. Chapter 8. What Perihelion Means. October 29th, 2025. That's the date everything hinges on. That's when 3I Atlas reaches perihelion, its closest point to the sun, and disappears from view behind our star. And according to Loeb, that's not just an inconvenient observational gap. It's potentially the most important moment of this entire encounter. When an object reaches perihelion, it's at the point in its orbit where the sun's gravity is strongest, velocity is highest, the curvature of the trajectory is sharpest. And if you want to make a major change to your orbit, if you want to slow down, speed up, or alter your course, that's when you do it. That's when a little bit of thrust gives you the biggest change in trajectory. It's called the Oberth effect, and it's a fundamental principle of orbital mechanics that every spacecraft designer knows. Normally, we use the Oberth effect to speed up. You fire your engines when you're moving fastest, when you're closest to a massive body like the sun or a planet, because that's when the kinetic energy you add has the most impact. Pioneer, Voyager, every probe we've ever sent to the outer solar system, they all use gravitational assists and carefully timed engine burns at perihelion to gain speed and reach their destinations. But the effect works in reverse too. You can use it to slow down, to brake, to bleed off velocity, and let gravity capture you into a bound orbit instead of an escape trajectory. This is called a reverse Oberth maneuver, and it's exactly what you would do if you wanted to transition from passing through a star system to staying in it permanently. Chapter 9. The Oberth window. 3I Atlas is currently on a hyperbolic trajectory. That means it's moving faster than escape velocity. It's going to swing around the sun and head back out into interstellar space, unless something changes, unless it slows down at perihelion. And the timing is remarkable. On October 29th, when 3I Atlas reaches perihelion, Earth will be on the exact opposite side of the Sunday. We'll be in what's called solar conjunction. The sun will be directly between us and the comet, and its glare will drown out any observation. Ground-based telescopes won't be able to see anything. Even space telescopes like Hubble and Webb, which aren't affected by daylight, will struggle because the sun's corona and brightness make it nearly impossible to image anything that close to the solar disk. Loeb describes this as a hidden vantage point. If you were designing a trajectory that allowed you to make a course correction unobserved, this would be it. You'd arrive at perihelion when the planet with the most advanced telescopes and the most interest in tracking you is on the far side of the star, and you'd make your maneuver while no one is watching. Is that intentional? Is it deliberate? Or is it just another coincidence in a long string of coincidences? If you take 3I Atlas's trajectory and vary its speed, slightly shift When it arrives at perihelion by a few days or weeks, the probability that Earth would be on the opposite side of the Sun at that exact moment is low. Not impossible, but low, maybe 1 in 20, depending on how you calculate it. Just another improbable thing stacked on top of all the other improbable things. But here's what makes this particularly significant. If 3I Atlas does make a maneuver on October 29th, if it fires engines or uses some propulsion system to slow down and capture itself into orbit around the Sun, we won't know immediately. We'll only find out weeks later when it re-emerges from behind the Sun in late November or early December and we recalculate its trajectory. At that point, if the orbit has changed, if 3I Atlas is no longer on an escape path, but instead on an elliptical orbit that keeps it in the solar system, we'll know something happened. We'll know a maneuver occurred. But we won't know exactly when or how or what kind of propulsion was used. All we'll have is the before and after, the trajectory going in and the trajectory coming out. Loeb calculates that if 3I Atlas does capture itself, if it transitions to a bound orbit, it could then make its way to Earth relatively quickly. The timeline he suggests is late November to early December for closest approach to our planet, not close in the sense of a collision. 3I Atlas will still be millions of kilometers away, but close enough that we'd have a much better view of it than we do now. And that raises the question of intent. If 3I Atlas is technological, if it's a probe or spacecraft of some kind, what would it want? What would be the purpose of staying in the solar system instead of just passing through? One possibility is observation. A probe designed to study inhabited worlds would want to stick around. It would want to orbit at a distance where it could monitor radio transmissions, watch for industrial signatures, track the movement of spacecraft and satellites. It would want to gather data over months or years, building a complete picture of the civilization it found. Another possibility is resource gathering. The solar system is full of useful materials. Water ice on comets and moons, metal-rich asteroids, helium 3 inches, the atmospheres of gas giants. An advanced civilization might send probes to catalog resources in star systems and identify targets for future exploitation. Or the purpose could be defensive. A probe that detects technological signatures, evidence of intelligent life, might be programmed to eliminate it before it becomes a threat. This is the dark forest scenario that Loeb references. The idea that revealing your existence to other civilizations is dangerous because you can't know their intentions. So, the safest strategy is to destroy any emerging intelligence you encounter before it develops the capability to threaten you. Loeb is careful to say he's not predicting this. He's not claiming 3I Atlas is a weapon or that we're in imminent danger, but he is saying that if we detect something technological, we need to assess the full range of possibilities, including hostile ones. We can't just assume benign intent. The good news, if you can call it that, is that we'll have some warning. If 3I Atlas does stay in the solar system, if it captures into orbit and starts maneuvering toward Earth, we'll see it coming. We'll have weeks or months to observe it, to try communicating with it, to figure out what it's doing and what it wants. That's very different from a surprise arrival with no time to react. But the window for that observation is narrow. From late November, when 3I Atlas re-emerges, until late December, when it makes its closest approach to Earth, we have maybe 4 to 6 weeks, and during that time, we need to be watching constantly. We need every telescope, every spacecraft, every sensor we have pointed at it. Loeb mentions in his writings that NASA's Juno probe, currently orbiting Jupiter, might be able to observe 3I Atlas when it passes near Jupiter in March 2026. ESA's JUICE spacecraft will have observations in November. Mars orbiters tracked it in early October. We should be coordinating all these assets, pooling the data, making sure we don't miss anything. Because if October 29th is the moment everything changes, if that's when 3I Atlas decides to stay, then we need to be ready for what comes next. And right now, we're not. We don't have a plan. We don't have an organization responsible for handling this scenario. We don't even have a consensus on whether we should be worried. Chapter 10. The Silence Protocol. Here's something most people don't think about. There are protocols for everything in space exploration. Protocols for equipment failure. Protocols for contamination. Protocols for detecting microbial life on Mars or Europa. Protocols for asteroid impacts that could threaten Earth. But there's no protocol for this. There's no international agreement on what to do if we detect an artificial object from another star system. No procedure for how to announce it. No framework for who decides what information gets shared with the public and when. That absence, that gap in our preparedness, creates a vacuum. And in that vacuum, decisions get made quietly, behind closed doors, by people who may or may not have the public's best interests at heart. When 3I Atlas was first discovered in July, the response was normal: scientific curiosity, public engagement. NASA's website had a dedicated page tracking the object. News outlets ran stories about our third interstellar visitor. But something shifted in late September. Posts about 3I Atlas started disappearing from social media platforms, not being flagged or marked as misinformation, actually vanishing. A Reddit user documented posting a detailed thread analyzing the chemical anomalies from the alleged ESA leak. The thread gained traction, accumulated hundreds of upvotes and dozens of comments within 2 hours. Then it was gone. Not removed with a moderator explanation, just deleted from existence. When the user tried to repost, the submission wouldn't go through. Shadow banned without notification or explanation. On Twitter now, X, several accounts noticed similar patterns. Astronomy Vibes, the account that went viral criticizing the ESA photos, reported significant engagement drops after October 7th. Posts that would normally reach tens of thousands of people were suddenly plateauing at a few hundred views. No official restrictions, no warning messages, just algorithmic suppression. Quiet enough to be deniable, but aggressive enough to be effective. YouTube presented a different problem. Content creators who posted analysis videos speculating about 3I Atlas began receiving demonetization notices. The stated reason varied. Some were flagged for discussing sensitive topics without proper context. Others were categorized as potentially misleading content about scientific matters. A few got hit with the vague but ominous label, content that may not be suitable for all advertisers. The pattern was clear. You could make a video saying 3I Atlas is definitely just a comet, and mainstream science has it figured out. That was fine. Monetized, promoted, but suggest there might be anomalies worth investigating. Suddenly your video becomes advertiser unfriendly. Facebook's approach was the most overt. The platform's fact-checking system, operated by third-party verification organizations, started aggressively labeling 3I Atlas content. Posts sharing the 4chan leak got slapped with missing context warnings. Claims about the trajectory anomalies were flagged as partly false, even when the posts were just quoting Avi Loeb's published calculations verbatim. The fact-check articles offered reassurance. Space agencies confirm no threat from interstellar comet. Experts say unusual features, likely natural processes. The subtext was clear. Don't worry. Don't speculate. Trust the authorities. Move along. The timing felt coordinated. All of this ramped up within 48 hours of the ESA photo release, right when public frustration was peaking over the lack of quality images. Now, to be fair, social media platforms suppress content all the time. Algorithms change, engagement fluctuates, fact-checkers flag misinformation. These are normal platform operations, not evidence of coordinated censorship. Unless there's a pattern, unless it's all happening at once, targeting one specific topic, right at the moment when public interest is highest and official answers are most absent. Some creators started using coded language to avoid suppression. Instead of 3I Atlas, they'd say the visitor or the object. Instead of alien or extraterrestrial, they'd use non-terrestrial or anomalous. It was like watching people develop a new vocabulary to discuss something the platforms didn't want discussed openly. The Streisand effect in real time. The more the content got suppressed, the more people assumed there was something worth hiding. The more aggressively fact-checkers pushed back, the less people trusted the official narrative. Every attempt to manage the conversation just amplified the suspicion that the conversation needed to be managed. Chapter 11. What December brings. By the time you're hearing this, it might already be too late to look. 3. Atlas will emerge from behind the Sun in early December. If it's still on its original hyperbolic trajectory, if it made no maneuver at perihelion, then it will continue moving away from us, gradually fading from view over the following months until it's too dim for even our best telescopes to track. A cosmic tourist that came and left, leaving us with more questions than answers, but no existential threat to worry about. That's the most likely outcome. That's what nearly every astronomer expects to happen. But if the trajectory has changed, if 3I Atlas emerges on a different path than it went in on, then everything shifts. December becomes the month we find out whether we're alone in a more immediate sense than we've ever had to consider before. Not, is there life out there somewhere in the galaxy, but is there something here, now, in our solar system, that didn't originate from our star? Loeb has been careful in his public statements to emphasize that even if 3I Atlas shows signs of technological origin, that doesn't automatically mean danger. An advanced civilization capable of sending probes across interstellar distances would presumably be advanced enough to have moved beyond conquest and destruction as primary motivations. But he's also honest about the unknowns. We have no framework for understanding alien intentions, no basis for predicting how a non-human intelligence might behave, no way to know whether peaceful exploration or resource extraction or preemptive elimination of potential competitors is the dominant strategy among technological species in the galaxy. The dark forest hypothesis suggests one possible answer, that silence is survival, that any civilization revealing its presence risks attracting attention from something more powerful, more aggressive, more willing to eliminate threats before they mature into competition. If that's the operating logic of the cosmos, then 3I Atlas, making itself visible, allowing us to detect it, track it, analyze it, would be unusual. Either it doesn't care about being observed, which suggests confidence born from overwhelming capability, or it wants to be observed, which raises the question of why. Reconnaissance? First contact? A test to see how we respond? Or something else entirely that we can't anticipate because we're working with a sample size of one technological civilization, our own, and no understanding of how typical or atypical our development has been. December will bring data. Hubble will track 3I Atlas as it emerges from solar conjunction. Webb will make its scheduled observations, examining the object's composition and activity state after perihelion. Ground-based telescopes will point toward it as soon as it's far enough from the Sun to observe safely. The trajectory will be recalculated. The orbit will be measured, and we'll know whether October 29th marked a turning point or just another data gap in a frustrating but ultimately mundane scientific investigation. But there's something else December might bring, something less tangible but potentially more significant, a shift in public consciousness about what's possible and what we should be watching for. For decades, the conversation about extraterrestrial intelligence has been theoretical. SETI, listening for radio signals, exoplanet surveys, looking for biosignatures in distant atmospheres, academic papers discussing the Drake equation and the Fermi paradox. All important work, all valuable, but all abstract, distant, easy to think about without having to confront the immediate implications. 3I Atlas, regardless of what it ultimately turns out to be, has made the conversation concrete. It's here. It's moving through our solar system right now. It passed Mars while we were watching. It will pass Earth in a few weeks. And the fact that we can't definitively rule out artificial origin, that we're having these discussions about trajectory alignments and missing data and government shutdowns and trajectory anomalies, means something has shifted. We're no longer just wondering if we're alone in the universe. We're wondering if we're alone in our own neighborhood. And that's a very different kind of question. Chapter 12, The Mars Question. Let's return to Mars, because that's where this story intersects with something older, something that's been building slowly over years of rover missions and orbital surveys and anomalous discoveries that never quite made sense. Mars has always been a strange place, not just geologically, though the ancient river valleys and lake beds tell us it once had liquid water, a thicker atmosphere, possibly conditions suitable for life, but strange in terms of what we keep finding that doesn't fit expected patterns. In 2015, the Curiosity rover photographed what looked like a perfectly rectangular stone, too geometric to be natural erosion, too regular in its proportions. NASA identified it as a ventifact, a rock shaped by wind-blown sand over millions of years into sharp edges and flat faces. Plausible. Wind erosion does create geometric shapes, but then similar formations started appearing in other locations. And the probability of multiple ventifacts forming with such regular geometry, scattered across different regions of Mars, starts to accumulate into something worth questioning. Then there were the spherules, tiny, perfectly round pebbles discovered by Opportunity in 2004, nicknamed blueberries, despite being gray. Their formation was eventually explained through natural processes, mineral precipitation in water-soaked rock, then erosion exposing the harder spherical cores. But the distribution was odd. They appeared in clusters, almost like they'd been manufactured and scattered, and their composition contained hematite concentrations, unusual for natural formation at those locations. None of this proves anything artificial. Geology is complex. Martian geology is even more complex because we're only beginning to understand how different atmospheric and chemical conditions create different erosion patterns and mineral deposits. But it creates context for what happened in Terra Meridiani. Amateur image analysts, poring over high-resolution orbital photographs from the Mars Reconnaissance Orbiter, started finding vertical structures, not small rocks or boulders, large formations, some appearing to be several kilometers tall, standing at angles inconsistent with typical layered sediment. NASA's explanation: more exotic geology. Layers of rock with different hardness levels eroding at different rates, creating structures that look artificial under certain lighting, but are entirely natural when examined in context. Again, plausible. Mars is full of unusual formations. The face on Mars turned out to be a mesa, a trick of light and shadow and human pattern recognition. Pareidolia is powerful. We see what we expect to see, especially in low-resolution imagery. But then 3I Atlas made its close approach to Mars on October 3rd, and suddenly those old anomalies were being re-examined. The vertical structures in Terra Meridiani, the geometric rocks scattered across multiple regions, the spherules, the ancient river valleys that stopped flowing millions of years ago for reasons we still don't entirely understand. What if they weren't geological? What if Mars has been occupied? Not recently, not by anything living now, but occupied in the past. A way station, a construction site, a testing ground. And what if 3I Atlas's trajectory wasn't random at all, but deliberately designed to pass close to Mars, to check on something that was left there long ago? This is where the narrative becomes difficult to navigate, because we're moving from verifiable anomalies, real measurements, real images, real calculations that show unusual alignments and missing data into pure speculation about ancient civilizations and long-term surveillance, and objects that might be doing things we can't observe with current technology. The evidence doesn't support drawing firm conclusions, but it does support asking uncomfortable questions. Why did 3I Atlas pass so close to Mars specifically? Why not Venus, which is actually closer to its perihelion point? Why not Earth, if observation of intelligent life is the goal? Mars is the obvious staging ground. It's far enough from Earth that activities there would be difficult to observe in real time. It has resources, water, ice, minerals, a solid surface. It once had a magnetosphere, an atmosphere, possibly life of its own billions of years ago. If you were designing a way station between interstellar space and the inner solar system, Mars would be the logical choice. And if 3I Atlas's purpose was to check on that way station, to deliver supplies or equipment or new construction materials, the close approach on October 3rd would make perfect sense. This is speculation. It needs to be clearly labeled as such, but it's speculation rooted in observable facts. The unusual trajectory, the missing data from Mars orbiters, the coordinated silence, the timing of the government shutdown, the suppression of discussion on social media platforms. Something doesn't add up. And when too many details don't add up, when too many coincidences stack on top of each other, it becomes reasonable to consider explanations that would normally seem far-fetched. Chapter 13. The construction hypothesis. If something is being built on Mars, if the vertical structures and geometric formations aren't natural geology, but artificial construction, then we need to ask, what are they building? The amateur analysts who first noticed the anomalies in orbital imagery proposed several theories. 1. Infrastructure for future habitation. Not by humans, but by whoever sent 3I Atlas. Launch pads, landing facilities, storage depots. The kind of groundwork you'd establish if you were planning to send crewed missions later. 2. Industrial processing facilities. Mars has mineral resources that might be valuable to spacefaring civilizations. Rare earth elements, metal ores, deuterium for fusion fuel. If you're mining asteroids and comets throughout the solar system, Mars could serve as a central processing and refining location. 3. Scientific instruments, telescopes, listening arrays, sensor networks designed to monitor the inner solar system and detect the emergence of technological civilizations on nearby planets. That last possibility is the most unsettling, because if they're watching, they've been watching for a long time. Long enough to see the first radio broadcasts from Earth in the 1,920 seconds. Long enough to track our development from primitive wireless telegraphy to nuclear weapons to spaceflight to the current era of global satellite networks and planetary rovers. They would know exactly what stage of development we're at. They would know our capabilities and our limitations. They would know whether we pose a threat or represent an opportunity, or should be left alone to develop naturally, and they would have had time to decide what to do about us. The WOW signal in 1977 could have been a ping, a radar sweep. We detect technological signatures from the third planet. Are you advanced enough to recognize this transmission? Are you listening? We heard it. We spent 48 years trying to figure out what it was, but we never answered. We never transmitted a reply, partly because we didn't know what we were replying to or where to aim our response. Maybe that was interpreted as insufficient development, not ready for contact yet. Check back later, and now, 48 years later, 3I Atlas arrives, moving through the solar system on a trajectory that brings it close to Mars, passes behind the Sun during perihelion when Earth can't observe it, potentially positions itself for long-term monitoring of our activities. The timeline makes a kind of sense. If you're studying emerging civilizations, you'd want periodic check-ins. You'd want to see how we've progressed since the last scan. Are we still fighting among ourselves? Have we developed interplanetary capabilities? Are we beginning to pose a threat to anyone beyond our own species? December will answer some of these questions. When 3I Atlas emerges from behind the Sun and we recalculate its trajectory, we'll know whether it captured into orbit or continued outbound toward interstellar space. If it continues outbound, then most of this speculation becomes academic. An interesting visitor with some unusual properties, ultimately just another comet from another star system passing through ours. But if it captured into orbit, then the construction hypothesis suddenly becomes something we have to take seriously, because objects don't accidentally break from interstellar speed and capture themselves into solar orbits. That requires either natural processes we don't understand or deliberate propulsion we haven't observed. And if it's the latter, if 3I Atlas used the perihelion passage on October 29th to slow down and stay, then whatever is being built on Mars becomes immediately relevant. Not a distant curiosity for future investigation. An active concern requiring immediate attention. Chapter 14. The government knows. There's a document that circulates in certain corners of the internet. It's called the Brookings Report, formerly titled Proposed Studies on the Implications of Peaceful Space Activities for Human Affairs. It was commissioned by NASA in 1960 and delivered to Congress in 1961. Most of it deals with mundane policy questions about space exploration, international cooperation, scientific research priorities. But there's a section, page 215 of the original document, that discusses something else entirely. What happens if we discover evidence of extraterrestrial life? The report suggests that such a discovery could be profoundly destabilizing to human civilization. It argues that societies throughout history have collapsed when confronted with technologically superior civilizations, and that the mere knowledge of more advanced beings existing elsewhere could trigger similar collapses in human culture, particularly in religious and philosophical frameworks. The recommendation, reading between the lines, is that such information should be carefully managed, released gradually, contextualized appropriately, not hidden exactly, but not announced without preparation for the social and psychological consequences. That was 1961, over 60 years ago. Since then, we've had decades of UFO sightings, government investigations, classified reports, slow drips of information, suggesting that something is being observed in our skies that we can't explain with conventional technology. The 2021 Pentagon report on unidentified aerial phenomena admitted that a majority of incidents remain unexplained. It carefully avoided using the word extraterrestrial, but acknowledged that some observed objects display capabilities beyond current human technology. That was a significant moment. The government essentially confirming that there are things flying around that we can't identify and don't understand, but it was also carefully controlled. The report raised questions without answering them. It acknowledged mystery without providing solutions. It told us just enough to know that something is happening, but not enough to understand what. 3i Atlas fits the same pattern. NASA has a dedicated page tracking the object. They've provided basic orbital parameters, size estimates, composition data. But the high-resolution images from the Mars flyby, still unreleased. The detailed spectroscopic analysis from multiple observatories, still being processed. The radio telescope observations, looking for potential transmissions, not mentioned. We get enough information to know that an interstellar object is passing through, but not enough to draw conclusions about what it might be beyond probably a comet. The government shutdown conveniently occurring during the Mars flyby observations feels like too perfect timing, as if someone knew that was the critical window and made sure that data release would be delayed, giving time to review what was captured, decide what can be shown publicly and what needs to remain classified. This sounds like conspiracy thinking, and maybe it is. But here's the thing about conspiracy theories. Sometimes they're correct. Sometimes powerful institutions do coordinate to manage information flow. Sometimes there are legitimate reasons for withholding data temporarily. The question is whether those reasons serve public interest or institutional interest. If HiRISE captured images showing clear artificial structures near 3i Atlas during the Mars flyby, that would be revolutionary. World-changing. The kind of discovery that rewrites textbooks and reshapes human understanding of our place in the cosmos. It would also trigger exactly the kind of societal disruption the Brookings Report warned about. Religious frameworks would need re-examination. Philosophical assumptions would collapse. Economic and political systems might destabilize as people questioned fundamental beliefs about human uniqueness and cosmic destiny. So maybe the images are being withheld not because they show nothing interesting, but because they show something too interesting. Something that requires careful preparation before public release. Something that changes everything. Or maybe they really do just show a fuzzy dot and bureaucratic delays during a government shutdown prevented timely publication of scientifically routine observations. We don't know. That's the frustrating part. We're left to speculate because the institutions that have the data aren't sharing it in the time frame we'd expect. Chapter 15. The December observation. If 3i Atlas emerges from behind the sun in early December, still on its original trajectory, this conversation becomes academic. An interesting case study in how quickly speculation can spiral when official information is slow or incomplete. A reminder that not every anomaly has sinister explanation, but if the trajectory has changed, then December becomes the most important month in human history, not because of war or plague or natural disaster, but because of confirmation, definitive proof that we share the cosmos with other intelligence, that we're not alone. that the structures and patterns we've been dismissing as geological formations, or imaging artifacts, or natural coincidences, are actually exactly what they look like. Evidence of construction, evidence of intention, evidence that someone has been here before us and might be here with us now. The implications cascade outward in ways that are difficult to fully comprehend. Every space program would need to be re-evaluated. Every mission plan would need to account for the possibility of encountering non-human technology. Every assumption about resource availability in the solar system would need to consider that those resources might already be claimed or monitored or off-limits by prior occupants. Earth's geopolitical landscape would shift. National borders and territorial disputes suddenly seem parochial when confronted with the reality that our entire species is a single, small civilization on one planet among many. The resource conflicts that drive wars would need reframing. The existential risks we face, climate change, nuclear weapons, pandemic disease, become more urgent because they threaten humanity's ability to join whatever larger community exists beyond our atmosphere. Religious and philosophical traditions would face fundamental challenges. The central role of humans in most theological frameworks doesn't easily accommodate the existence of other intelligent species. Some traditions would adapt, others might fracture. Scientific progress would accelerate dramatically. Access to technology, even slightly more advanced than our own, would provide insights into physics, materials, science, propulsion systems, energy generation that might otherwise take centuries to develop independently. But there are darker possibilities too. If 3i Atlas represents surveillance rather than greeting, if it's here to assess whether we're a threat, then our response to its presence becomes critically important. Aggressive posturing would confirm fears. Military mobilization would suggest hostility. Broadcasting demands for information or attempts to establish forceful contact might be interpreted as exactly the kind of dangerous behavior that justifies preemptive action. The safest approach would be observation, careful study, attempts at peaceful communication, demonstrating that we recognize our limitations and are willing to learn rather than conquer. But that requires international coordination, unity of purpose, agreement on who speaks for humanity and what messages we send. And right now, we don't have those frameworks. We're fragmented, competitive, struggling to solve problems within our own species before confronting the implications of species beyond it. Which brings us back to the silence. The missing data, the suppressed discussions, the coordinated lack of information. Maybe that's by design. Maybe someone in a position to see the full picture has decided that humanity isn't ready, that the destabilization would outweigh the benefits. That revealing what was seen during the Mars flyby would trigger exactly the kind of chaos that makes us look dangerous to whatever intelligence might be watching. So they're buying time, managing the release, preparing for gradual disclosure rather than sudden revelation. Or maybe there's nothing to reveal. Maybe the silence is just bureaucratic incompetence, and the missing images are stuck in processing pipelines. And the conspiracy theories are exactly that, theories constructed from pattern recognition run amok. December will clarify. One way or another, the trajectory will be measured, the orbit will be calculated, and we'll know. Chapter 16, what building means. If we accept, purely as intellectual exercise, that something is being built on Mars, that the structures observed in orbital imagery are artificial rather than geological, then we need to ask what building actually means in this context. Our understanding of construction is rooted in human scale and human purpose. We build shelters for protection, factories for manufacturing, launch facilities for accessing space. Everything we construct serves an immediate practical function tied to survival, resource extraction, or expanding our presence. But a civilization millions of years more advanced than ours would have different needs, different scales, different definitions of what constitutes useful construction. They might not need physical shelters if they've transcended biological form. They might not need factories if they've mastered molecular assembly or nanotechnology. They might not need launch facilities if they've developed propulsion systems that don't require massive infrastructure. So what would they build? One possibility: information processing. vast computational networks designed to run simulations, model civilizations, predict outcomes, test hypotheses about the development of intelligence in different environments. Mars could be a giant server farm, crunching data on everything happening in the solar system. Another possibility, terraforming. Not for immediate habitation, but as long-term projects spanning millions of years, slowly modifying Mars's atmosphere, rebuilding its magnetosphere, establishing the groundwork for eventual ecosystem development. We wouldn't see the immediate effects, but millennia from now, Mars might have breathable air and liquid water and conditions suitable for life as we know it. A third possibility, art. Construction for aesthetic or philosophical reasons we can't comprehend. Monuments, sculptures, physical expressions of concepts that don't translate to human understanding but hold significance in whatever framework guides their civilization's values. Or maybe building isn't happening at all. Maybe what we're interpreting as construction is actually archaeology. Maybe Mars was inhabited billions of years ago, and what we're seeing are ruins being excavated, old structures being uncovered, ancient technology being recovered and studied. That would flip the entire narrative. Instead of fearing an invasive presence constructing things on Mars, we'd be looking at evidence of a civilization that existed here long before Earth developed complex life. Possibly even a civilization native to Mars itself, before the planet lost its atmosphere and became the cold desert it is today. If that's the case, then 3I Atlas could be a maintenance probe, checking on excavation sites, collecting samples, ensuring that whatever is being preserved or recovered from ancient Mars remains undisturbed by the emergence of humans exploring the planet with their rovers and landers. We tend to think of space as empty. We think of planets as unclaimed territory, free for whoever gets there first to explore and exploit. But if intelligent life is common in the galaxy, if technological civilizations arise frequently and last for millions of years, then most of the cosmos might already be spoken for. Mars might not be virgin territory. It might be someone's archaeological site, or their testing ground, or their early warning system, or their art project. And our presence there, with perseverance and curiosity and insight, and all the orbiters and past landers, might be the cosmic equivalent of children stumbling into a museum and touching artifacts they don't understand. Not necessarily dangerous, not automatically hostile, but potentially problematic if we damage something important or interfere with processes we can't see. The October 3rd flyby could have been inspection, making sure our activities aren't causing problems, checking whether we're approaching, understanding of what we're looking at, deciding whether we're advanced enough to be brought into the loop or whether we need more time to develop before being told what Mars actually is. Chapter 17. The Countdown. As I record this, we're approximately 3 weeks from December emergence. 3 weeks until 3I Atlas comes out from behind the sun and we get our first trajectory update since perihelion. Professional observatories are preparing. Hubble has scheduled time. Webb has observation windows booked. Ground-based facilities in both hemispheres are coordinating to ensure continuous coverage during the critical reacquisition period. Amateur astronomers are ready too. Backyard telescopes pointed toward the expected emergence coordinates. Online communities coordinating observations, planning to pool data, determined to have independent verification of whatever official sources report. This time, there won't be the excuse of government shutdowns or equipment limitations. Multiple independent observers will be tracking 3I Atlas. If the trajectory has changed, someone will notice. If the orbit is different, multiple groups will calculate it and cross-check their results. The science will happen whether institutions cooperate or not. And that's actually the most interesting shift that's occurred over these months since July. The democratization of space observation. The recognition that we don't have to rely solely on official announcements to understand what's happening in our solar system. Citizen science has been growing for decades, but 3I Atlas has accelerated that growth. Thousands of people who never thought about interstellar objects before are now following the story. Learning orbital mechanics, understanding spectroscopy, teaching themselves how to process astronomical data and verify claims. That community will be watching in December. And whatever emerges from that observation, whatever the trajectory shows, will be scrutinized by far more eyes than any previous space science discovery, which creates its own pressure on institutions to be transparent, because hiding or spinning or managing information becomes much harder when hundreds of independent observers have access to the same data and the technical knowledge to interpret it correctly. If 3I Atlas has captured into orbit, that will be clear within hours of reacquisition. The orbital elements will be obvious. The change from hyperbolic to elliptical trajectory will be mathematically undeniable. And at that point, the conversation shifts from "is it artificial?" to "what do we do now?" Because an object from another star system that deliberately braked and chose to stay in our solar system represents a fundamentally different situation than a natural comet passing through. It means someone sent it here. It means they wanted it to stay. It means they're interested in something about our solar system, specifically whether that's the sun's energy output, the arrangement of planets, the presence of technological civilization on Earth, or something else entirely that we haven't considered. And it means we have to decide how to respond. Do we attempt communication? Try to send signals toward it? Establish some kind of dialogue? Make our presence and intentions known? That's the optimistic approach. The assumption that any species capable of interstellar travel would be peaceful, curious, interested in meeting other intelligent life. But there's risk in revealing ourselves. If they don't know about us yet, if they're here for resources, or scientific observation of planetary formation, or some other purpose, unrelated to humanity, then broadcasting our existence might draw attention we're not prepared for. The dark forest hypothesis argues that silence is survival, that revealing your location to unknown intelligences is the cosmic equivalent of shouting your address in a dangerous neighborhood. You might attract a friendly visitor, or you might attract something far worse. Loeb has been vocal about his position. We should engage. We should attempt communication. We should act as if peaceful contact is possible, because the alternative, assuming hostility and hiding guarantees, will never make contact, even if the intentions are benign. But Loeb is one voice among many in the scientific community, and there's no consensus on proper protocol. There's no unified response plan. No international agreement on who gets to make these decisions on behalf of the entire human species. So we wait, and watch, and prepare for whatever December brings. Chapter 18. The pattern of visitors. Let's step back and look at the larger context. 3I Atlas is the third confirmed interstellar object we've detected, but it's worth examining the pattern established by its predecessors. Oumuamua in 2017 was the first, a small, cigar-shaped object tumbling through the inner solar system at high speed. It exhibited slight non-gravitational acceleration, a push that couldn't be explained purely by gravity. The natural explanation was outgassing, like a comet, though no coma was observed. Loeb proposed an alternative, a light sail, an artificial structure pushed by solar radiation pressure. The scientific community largely rejected that interpretation, not because it was impossible, but because natural explanations seemed more probable. Comets can outgas without visible comas under certain conditions. The acceleration could be explained without invoking technology. Then came 2I Borisov in 2019, a clear comet, behaving exactly as expected. Coma, tail, spectroscopic signatures matching solar system comets. Nothing unusual. A cosmic tourist that confirmed interstellar objects could be exactly what they appeared to be: natural debris from planet formation ejected into the galactic void. Now, 3I Atlas, different from both predecessors, more active than Oumuamua, but with unusual chemistry compared to Borisov, larger, faster, following a trajectory that seems too convenient to be random, but could still be coincidental. 3 objects, 3 data points, not enough to establish firm patterns, but enough to start asking questions. Are interstellar visitors increasing in frequency? Are we getting better at detecting them, or are more of them arriving? The Vera C. Rubin Observatory, which just became operational in 2025, is expected to detect one interstellar object every few months once it's running at full capacity. That's a dramatic increase from the current rate of roughly one every few years. If that prediction holds, we'll have dozens of interstellar objects catalogued within the next decade. And with larger sample sizes come better statistics. We'll be able to see whether 3I Atlas's trajectory is genuinely anomalous or falls within expected variation. We'll be able to compare chemical compositions, outgassing rates, structural characteristics. We'll start to understand whether the galaxy is full of interstellar debris or whether some fraction of that debris isn't debris at all. But here's what's interesting about the timing. Rubin came online in 2025. 3I Atlas was discovered in 2025. The massive increase in detection capability coincides with what might be the most controversial interstellar object yet discovered. That could be coincidence. Better instruments find more interesting things simply because they're looking more carefully. Or it could suggest that interesting things arrive more often than we realized, and we've been missing them because our detection capabilities were inadequate. How many interstellar visitors passed through the solar system in the decades before we had the technology to spot them? And if they're common, if the galaxy is full of objects traveling between stars, then the question becomes whether any significant fraction of them are artificial. Because even a small percentage applied to large numbers starts to add up to something notable. If 1 in 1,000 interstellar objects is technological, and Rubin detects hundreds over the next decade, then we should expect to find a few that show clear signs of artificial origin. Are we ready for that? As a species, as a civilization, as a collection of governments and institutions that can barely coordinate on terrestrial challenges? Probably not, but ready or not, December is coming, and December brings answers. Chapter 19, The Silent Transmission. There's another piece to this story that hasn't gotten enough attention, one that connects the 1977 WOW signal to current events in a way that's either profound coincidence or careful planning. When the Big Ear telescope detected that 72-second burst of energy on the 15th of August 1977, it was recorded on paper printout, a continuous roll of perforated paper tracking signal intensity across different frequencies. The printout showed nothing, nothing, nothing. Then suddenly a spike so strong that Jerry Eamon circled it and wrote, "Wow," in the margin. The signal intensity was measured in Jansky's units of spectral flux density. The WOW signal peaked at around 212 Janskys, roughly 30 times stronger than background noise. Translated to actual power output, if the source was at 3I, Atlas's estimated distance in 1977 about 600 AU, that corresponds to a transmitter output between 0.5 and 2 gigawatts focused into a narrow beam. That's nuclear power plant levels of energy, enormous by human standards, but potentially quite reasonable for an advanced civilization trying to send a detectable signal across interstellar distances without wasting energy on omnidirectional broadcasting. The frequency was also significant, 1,420.456 megahertzes. That's the hydrogen line, the most abundant element in the universe. Any technological civilization studying the cosmos would know this frequency. It's the universal channel, the obvious choice for attempting interspecies communication. The signal was also narrowband, confined to a very specific frequency range rather than spread across the spectrum. Natural cosmic phenomena tend to produce broadband noise. Narrow signals suggest artificial generation, something designed to stand out against natural background. And then, nothing. 48 years of silence. Hundreds of follow-up observations pointed at the same coordinates in Sagittarius. Different telescopes, different frequencies, different search parameters, all negative, as if the signal was a one-time pulse rather than continuous transmission. Which makes sense if you're conducting a survey. You don't broadcast continuously. You ping each star system once, listen for response, move on if you hear nothing. Energy conservation. Efficient use of resources. But then why did 3I Atlas take 48 years to arrive after the signal? If the signal was sent from 600 AU away in 1977, and the object is traveling at 58 kilometers per second relative to the Sun, the travel time would be about 48 years. The math is almost too neat, too convenient. It suggests the WOW signal wasn't a survey ping at all. It was an announcement. We're coming. We've detected your technological signatures. Here's proof. We're capable of directed transmission. We'll arrive in your star system in about 5 decades. That's sufficient warning time for a civilization to prepare, to develop better detection capabilities, to build infrastructure for observation and potential communication, to have public discourse about how to respond to visitors from beyond. We had 48 years, and we spent most of that time arguing about whether the signal was real, where it came from, whether it was natural or artificial, whether we should respond or stay silent. We never reached consensus. We never prepared protocols. We never unified our response strategy. And now the object that might have sent that signal is here. Has been here since July, passed Mars in October, reaches perihelion this month, emerges in December. The timeline suggests intentionality, calculation, a carefully planned trajectory designed to give us time to notice, time to prepare, time to decide how we want to interact. Or it's all coincidence. The WOW signal was natural phenomena we still don't understand. 3I Atlas is a comet with unusual chemistry. The directional alignment is statistical luck. The 48-year gap is numerological apophenia, seeing patterns where none exist. But here's what makes the silence so conspicuous. Not a single major radio telescope has publicly reported attempting to listen to 3I Atlas. The Very Large Array hasn't announced observations. Green Bank hasn't published data. The Allen Telescope Array, specifically designed for SETI work, has been oddly quiet about whether they've pointed at the most interesting interstellar object in decades. Either they're not looking, which seems like a massive oversight given the potential significance, or they're looking but not sharing results, which raises the question of why. What would make radio astronomers detect something and choose not to announce it? What would make SETI researchers, whose entire purpose is finding evidence of extraterrestrial intelligence, stay silent about a potential detection? Fear, uncertainty about interpretation, institutional pressure to avoid announcing something extraordinary without overwhelming evidence, the memory of past false alarms and the professional damage they caused. Or maybe they're looking and finding nothing. Radio silence from 3I Atlas. No transmissions, no signals, just an inert rock from another star system, behaving exactly as a natural comet should, which would actually be reassuring. It would mean the WOW signal remains unexplained but unconnected. It would mean 3I Atlas is what it appears to be. It would let us return to the comfortable assumption that we're alone until proven otherwise. But the silence itself, the absence of announcements about whether anyone is listening, creates room for speculation, room for doubt, room for wondering what's being observed that we're not being told about. Chapter 20. The Cost of Knowing. There's a thought experiment in philosophy about the value of truth. Imagine you're living in a simulation. Everything you experience, everyone you know, every memory you have, it's all artificial, generated by computers running some kind of ancestor simulation or entertainment software or scientific experiment. Would you want to know? Most people say yes immediately. Of course we'd want to know. Truth is valuable. Reality matters. Living in ignorance is no life at all. But then you dig deeper. What would change if you knew? You'd still experience the same sensations, have the same relationships, face the same challenges. The only difference is that you'd know it's simulated, and that knowledge would fundamentally alter how you relate to everything. Would you care about your family if you knew they were artificial constructs? Would you pursue goals if you knew the entire framework was illusory? Would existence retain meaning if you understood that the reality behind it was computational rather than physical? For many people, knowing would be devastating. The revelation would undermine everything they base their lives on. They'd be happier, not knowing, living within the comfortable illusion, finding meaning in relationships and achievements, even if none of it is real in the ultimate sense. That's the dilemma we face with 3I Atlas. If it's artificial, if December confirms that it captured into orbit and begins demonstrating technological capabilities, then everything changes. Our understanding of our place in the cosmos, our assumptions about human uniqueness, our frameworks for meaning and purpose and destiny. Some people will handle that revelation well. They'll be excited, curious, eager to learn more. They'll see it as the most important discovery in history and embrace the opportunity to interact with intelligence from beyond Earth. But many people won't. For them, the revelation will be destabilizing. Their religious frameworks might collapse. Their sense of security in a comprehensible universe might shatter. They might retreat into denial or conspiracy theories or apocalyptic thinking. Governments understand this. The Brookings Report spelled it out clearly in 1961. Discovery of extraterrestrial intelligence could trigger societal collapse, particularly in cultures heavily invested in religious or philosophical frameworks that place humans at the center of cosmic significance. That's why information might be managed carefully. Not hidden exactly, but released gradually, contextualized, surrounded by reassurance and guidance about how to interpret it without panic. But there's a cost to that approach too. When institutions manage information flow, they erode trust. People recognize when they're being handled. When data is selectively released or carefully spun or conspicuously absent, it triggers suspicion that something is being hidden, and that suspicion can be more damaging than the truth would have been. Because while truth provides certainty, suspicion breeds endless speculation. People fill information gaps with increasingly extreme theories. The absence of official explanation becomes evidence of conspiracy. We're seeing that pattern play out right now. The missing Mars flyby images, the delayed data releases, the social media suppression, the coordinated silence from multiple space agencies. Maybe there's legitimate reason for caution. Maybe what was observed needs careful analysis before public announcement. Maybe institutional processes are just slow and we're witnessing normal bureaucratic delay rather than deliberate information management. But the longer the silence continues, the more people assume something is being hidden, the more elaborate the theories become, the less trust exists in official sources. So there's a dilemma. Release information immediately and risk destabilizing revelation, or manage the release carefully and risk erosion of trust that makes eventual revelation even more destabilizing, because people no longer believe anything they're told. There's no good answer, no perfect path, just different costs associated with different choices. And December is when those choices crystallize. When the trajectory is measured and the orbit is calculated and we know definitively whether 3I Atlas stayed or left. If it left, this conversation becomes academic. Interesting case study. Lesson learned about information management and public communication during scientific uncertainty. But if it stayed, then we're in uncharted territory. Then every choice about what to reveal and when to reveal it carries enormous weight. Then the cost of knowing becomes real and immediate and unavoidable. Chapter 21. The Mars Samples. There's one more layer to this story that hasn't received adequate attention. Something that connects 3I Atlas to Mars to Earth to decisions being made right now about sample return missions. NASA's Perseverance rover has been collecting samples from Jezero crater since February 2021. Carefully selected rock cores sealed in titanium tubes, cached at specific locations across the crater floor, waiting for a future mission to retrieve them and bring them back to Earth. The Mars Sample Return Mission is one of the most expensive and complex space projects ever conceived. Multiple launches, orbital rendezvous at Mars, sample retrieval from the surface, launch from Martian surface back to orbit, capture and return to Earth, entry, descent, and landing protocols that ensure the samples don't contaminate Earth's biosphere. Billions of dollars, international cooperation between NASA and ESA, multiple spacecraft working in concert, all to bring back a few kilograms of Martian rock and soil. Why? The scientific justification is sound. Mars samples, analyzed in Earth laboratories with sophisticated equipment, could definitively answer questions about past habitability, potential biosignatures, geological history, things we can't determine with rover instruments alone. But there's another possibility that's rarely discussed publicly. What if the samples aren't primarily about natural Martian geology? What if Perseverance has been documenting something artificial? Look at the rover's path through Jezero crater. It's systematic, methodical, targeting specific formations, avoiding others. The sample collection sites aren't random. They follow a pattern that suggests, actually, we don't know what pattern they follow because NASA hasn't fully explained the selection criteria. They cite scientific interest in sedimentary layers, delta deposits, ancient lake beds, all legitimate targets, all consistent with studying Mars's geological history. But Jezero crater is also where some of the most interesting orbital anomalies have been observed. Geometric formations, unusual rock arrangements. That controversial doorway, photographed by Curiosity in Gale crater, might have equivalents in Jezero that haven't been publicized. What if Perseverance has been quietly collecting samples of artificial structures, or rocks showing evidence of past technological activity, or materials that don't match expected Martian composition but suggest manufacturing or processing? Those samples would be invaluable, but they'd also be controversial, potentially civilization-altering, the kind of discovery that requires careful analysis and verification before announcement, and they'd be exactly the kind of samples you'd want to bring back to Earth before anyone else had a chance to examine them or claim priority. Now consider the timing. Mars sample return was supposed to launch in the late 2022. Budget overruns and technical challenges have delayed it. Current estimates suggest early 2032 at earliest for sample return to Earth. But 3I Atlas arrives in 2025, makes its close approach to Mars in October, potentially captures into solar orbit in December. If 3I Atlas is interested in Mars, if its trajectory was designed to check on something there, then the samples Perseverance has collected become more significant. They're evidence of what was found, documentation of what exists, material proof that could be analyzed independently. Getting those samples off Mars and back to Earth becomes urgent in a way it wasn't before. Not just scientific curiosity, but strategic necessity. Because whoever controls the samples controls the narrative about what's actually on Mars. This might explain some of the urgency around Mars sample return despite budget constraints. This might explain why alternative approaches and cost reduction measures are being explored so aggressively. Get those samples back before circumstances change, before access to Mars becomes complicated by presence of other interested parties. This is speculation layered on speculation, building castles from sand, connecting dots that might not form any actual picture. But the dots exist, the samples exist, the planned retrieval exists, the timing of 3I Atlas exists, and the uncomfortable silence about what those samples might contain continues. Chapter 22. The December Protocols. Let's talk about what actually happens when 3I Atlas emerges from solar conjunction in early December. First, reacquisition. Multiple telescopes will begin searching the expected coordinates as soon as the object is far enough from the Sun to observe safely. This typically happens when the solar elongation, the angular distance between the object and the Sun as viewed from Earth, exceeds about 30 degrees. For 3I Atlas, that should occur around December 4th or 5th, depending on its exact trajectory. Ground-based observatories in the southern hemisphere will have first chance at detection, since the comet will be visible in pre-dawn skies from that latitude. Within hours of first detection, observations will be shared across the international astronomical community. The Minor Planet Center will collect data from multiple sources and calculate preliminary orbital elements. This is where we'll get our first indication of trajectory change. If the orbit is still hyperbolic, if the eccentricity remains above 1, then 3I Atlas is still on an escape trajectory. It's leaving the solar system as expected. Case closed, mostly. But if the eccentricity has dropped below 1, if the orbit has become elliptical, then we know something changed at perihelion. A maneuver occurred. The object braked and captured itself into solar orbit. That determination will be made within 24 hours of reacquisition. The math is straightforward. The orbit either is or isn't bound. There's no ambiguity once you have enough positional measurements. And at that point, everything changes. NASA will call an emergency press conference. Not immediately, they'll want time to verify the data, run models, understand implications, but within days, they can't sit on information of that magnitude. Too many independent observers will have the same data. The calculation will be confirmed by amateur astronomers, universities, international space agencies. Attempting to suppress or delay would be pointless and counterproductive. The announcement will be carefully worded, emphasis on continued analysis, caution about jumping to conclusions, acknowledgement that bound orbit doesn't necessarily imply artificial origin. Natural capture scenarios will be explored, even if they require unusual physics, but the subtext will be clear. Something unprecedented has occurred. An interstellar object has chosen to stay in our solar system. The implications deserve serious attention. What follows will depend on observational data collected in subsequent days and weeks. Does 3I Atlas begin actively maneuvering? Does it change its orbit further? Does it move toward a specific target Earth, Mars, Jupiter? Or does it settle into a stable, elliptical orbit and become passive? Just sitting there, a permanent resident of our solar system, not actively threatening, but unnervingly present. Radio telescopes will be deployed immediately. The Very Large Array, Green Bank, Fast in China, all will turn toward 3I Atlas and listen across all frequencies. If there's any transmission, any signal, any evidence of communication capability, we'll detect it. And if we do detect a signal, then protocols exist sort of for how to respond. SETI has draft procedures for confirming extraterrestrial intelligence and deciding whether to reply. The Outer Space Treaty and other international agreements provide frameworks for cooperation on matters of cosmic significance. But those protocols have never been tested in real scenario. They're theoretical, aspirational, built on assumptions about how rational institutions will behave when confronted with unprecedented situations. Reality is likely to be messier. Competing national interests, disagreement about interpretation, confusion about who has authority to make what decisions on behalf of humanity. The first few weeks after a confirmed orbital capture will be chaotic. Not violent or dangerous necessarily, but disorganized. Multiple actors, pursuing different goals, with incomplete coordination. Eventually, some form of international framework will emerge. The UN will convene emergency sessions. Scientific organizations will issue position papers. Religious leaders will offer theological perspectives. Governments will stake out positions. And gradually, a new normal will establish itself. One that includes the reality of non-human intelligence existing in our solar system. One that accepts we're not alone and begins grappling with what that means for how we organize ourselves, how we explore space, how we think about our future. But that's assuming December confirms orbital capture. If the trajectory shows 3I Atlas is still leaving, if the orbit remains hyperbolic and the object continues outbound on its original path, then none of this happens. We return to speculation. The anomalies remain unexplained but unthreatening. The missing data stays missing. The theories persist but lack definitive proof. And we wait for the next interstellar visitor, knowing that Rubin will find them regularly now, wondering if the next one will be the one that changes everything. 3 weeks until we know. 3 weeks until December answers questions we've been asking since July. The countdown continues. Chapter 23. The Philosophical Weight. There's an essay by Arthur C. Clarke called The Star. It's about a Jesuit priest serving as astronomer on a deep space expedition. His ship discovers the remnants of a dead civilization, a species that created art, literature, technology, culture, all of it preserved in a vault on the outermost planet of their system. The civilization was destroyed by their star-going supernova. They knew it was coming, had time to document everything they were, everything they'd achieved, sealed it away, hoping someone would find it and know they existed. The priest struggles with theodicy, how to reconcile a benevolent God with a universe that allows entire civilizations to be obliterated through natural process. Billions of sentient beings, rich with culture and love and meaning, extinguished without warning or purpose. And then he makes a calculation. He determines the date of the supernova, back calculates the distance to Earth, figures out when the light from that explosion would have reached our planet. It was the Star of Bethlehem. The death of an alien civilization was the astronomical event that marked the birth of Christ. The story ends there. Clarke doesn't resolve the theological implications. He just presents the situation and lets it sit, heavy and uncomfortable. That's the kind of weight we might be facing with 3i Atlas. Not necessarily theological, though religious frameworks will certainly be challenged, but philosophical. The weight of confronting something that forces reconsideration of fundamental assumptions. Humans have a tendency toward exceptionalism. We think we're special, central. The reason the universe exists in the form it does. Every culture throughout history has placed itself at the center of cosmic significance. The Copernican revolution displaced Earth from the center of the solar system. The recognition that the Milky Way is one galaxy among billions displaced us from the center of the cosmos. The acknowledgement that our sun is an ordinary star and Earth is an ordinary planet displaced us from cosmic uniqueness. But we've maintained psychological centrality. We might not be physically unique, but we're still the only intelligence we know, the only ones who can appreciate the universe, understand it, give it meaning through conscious observation. Confirmation of extraterrestrial intelligence would be the final displacement. We're not even unique in consciousness, not special in our ability to think, create, explore. Just one species among potentially many, all doing roughly the same things at different scales and stages of development. Some people will find that liberating. A relief from the burden of cosmic isolation. Evidence that intelligence is normal rather than miraculous. Confirmation that we're part of a larger community rather than alone in the void. But others will find it devastating. A fundamental undermining of meaning and purpose. If we're not special, if there's nothing unique about human consciousness or achievement or potential, then what's the point? Why does anything we do matter in the larger cosmic context? That's the philosophical weight, the existential challenge of adjusting self-conception to accommodate reality that's larger and more complex than we hoped, and it will affect different communities differently. Western secular culture might adapt relatively quickly. The framework already includes evolution, cosmic history, multiple civilizations on Earth with different cultures and values. Adding extraterrestrial intelligence to that framework is difficult but conceptually manageable. Religious communities face harder adjustments. Most theological traditions place humans in unique relationship with the divine. We're created in God's image. We're the reason for creation. Salvation history is our story specifically. What happens to those frameworks when other intelligent species exist? Are they also created in divine image? Do they have their own salvation histories, their own relationships with the divine? Or does the very concept of the divine need reconsideration in light of multiple intelligences distributed throughout the cosmos? Some religious traditions will adapt. They'll find theological room for extraterrestrial intelligence, expand their interpretations, maintain core beliefs while adjusting peripheral doctrines. Others won't. They'll reject the evidence or retreat into increasingly defensive positions. The friction between observation and doctrine will create fractures within faith communities that might take generations to resolve. And then there are the practical questions. How do we interact with intelligence that might be millions of years more advanced? What do we have to offer? What do we risk by engaging? If 3i Atlas demonstrates technological capability, if it captured into orbit through deliberate propulsion, then we know we're dealing with civilization that can do things we can't. Send objects across interstellar distances, navigate complex gravitational systems, potentially communicate across vast timescales. We become the less developed species, the newcomers, the ones lacking understanding of how the galaxy actually works. That's humbling, potentially frightening, definitely challenging to navigate without established protocols or understanding of what's expected or appropriate. Do we attempt communication? Wait for them to initiate? Study them quietly and hope they don't notice us? There's no right answer because we don't have enough information. Don't understand their intentions, capabilities, cultural frameworks, decision-making processes. We're fumbling in the dark, making it up as we go, hoping we don't accidentally do something that triggers hostile response or violates some cosmic protocol we're unaware of. That's the philosophical weight. Not just abstract questions about meaning and purpose, but immediate practical challenges about how to function in a universe that includes other intelligence with capabilities exceeding our own. December will clarify whether this is hypothetical philosophical exercise or practical immediate problem requiring urgent attention. Chapter 24. The construction continues. Let's return one more time to the Mars question. Because if 3I Atlas is connected to Mars, if its close approach on October 3rd was deliberate, then we need to understand what might actually be under construction. The orbital imagery shows vertical structures in Terra Meridiani region. Multiple formations, kilometers tall, standing at angles that don't match typical geological layering. When examined in different wavelengths, visual, infrared, radar, they show unusual properties. Radar reflective surfaces that shouldn't exist on natural rock formations, thermal signatures that don't match the surrounding terrain. NASA's explanation, unusual mineral composition, combined with viewing angle and processing artifacts. The structures are natural geological features that happen to look artificial under certain observation conditions. That explanation worked when they were anomalies existing in isolation. Interesting, but not threatening. Curiosities worth noting, but not worth obsessing over. But context changes interpretation. When you add 3I Atlas passing unusually close to Mars, during exactly the period when Earth-based observation is impossible, those structures become more interesting. When you add the missing data from multiple Mars orbiters, they become suspicious. When you add the government shutdown timing and the social media suppression, they become urgent. What if the structures aren't ancient? What if they weren't built millions of years ago by a long-dead civilization? What if they're being built now? What if 3I Atlas didn't just pass by Mars, but actually deployed something? A lander, construction equipment, automated systems designed to continue work on projects that have been progressing for how long? Decades? Centuries? Millennia? We've been observing Mars with orbiters since the 1970 seconds. Detailed surface mapping since the 1990 seconds. High-resolution imagery since the 2000s. If something was building on Mars during that entire time, we would have noticed changes in the terrain. New structures appearing, old structures growing, evidence of ongoing activity, unless they're very good at hiding. Unless the construction is happening underground, unless what we see in the orbital imagery isn't the actual building, but just surface infrastructure, ventilation shafts, access portals, antenna arrays. The bulk of the construction could be happening beneath the surface, hollowing out caverns, establishing habitable spaces, installing equipment and systems that don't show up in visible light imagery. That would explain why the rover images from the surface rarely show anything obviously artificial. You can't see underground construction from ground level. You'd only notice surface features, and those could be disguised or designed to look natural from certain perspectives. It would also explain why the orbital anomalies are concentrated in specific regions. If construction is happening at particular sites chosen for geological or strategic reasons, you'd expect to see infrastructure clustered around those sites, rather than randomly distributed. Terra Meridiani is geologically interesting. Ancient sedimentary deposits, evidence of past water, relatively flat terrain, suitable for landing large equipment. If you were choosing location on Mars for underground construction, that region would be a reasonable choice. And if 3I Atlas's mission was to deliver supplies or new equipment or check on construction progress, then the October 3rd close approach makes perfect sense. Orbital mechanics would dictate that timing. You arrive when Mars is positioned correctly. Relative to the Sunday, you use the close approach to deploy whatever needs deploying, or verify whatever needs verification. You continue on your trajectory, potentially capturing into solar orbit if ongoing monitoring is required. This is speculation built on speculation, built on anomalous imagery that might have entirely natural explanations. But the pattern is there, the data points exist, and the refusal to provide transparent answers makes the speculation inevitable. If construction is happening, if something is actively building infrastructure on Mars right now, then the question becomes, Building what and for who? A base? A outpost? A research station? A mining operation? A way station for missions going deeper into the solar system or back out to interstellar space? Or something else? Something we wouldn't recognize because our framework for understanding construction is limited to human needs and human scales. Maybe they're building a beacon, a navigation marker, something that helps other interstellar visitors find the system and understand its properties. Maybe they're building a defensive installation, something designed to detect and potentially deter threats. Early warning system for the inner solar system. Maybe they're building a garden, biological preservation facility, storing genetic information or living specimens from civilizations throughout the galaxy. Or maybe they're building something so far beyond our current comprehension that we wouldn't recognize it even if we saw it directly. Like an ant trying to understand why humans build particle accelerators. The purpose and function exist at a cognitive level the ant can't access. That's the humbling possibility. That even if we discovered what's being built, we wouldn't understand what it's for. Chapter 25. The December Darkness. We're now in the final stretch. Days away from early December. Days away from when 3I Atlas should emerge from behind the sun and give us our first post-perihelion observations. The astronomical community is ready. Telescopes are scheduled. Observation plans are coordinated. Amateur astronomers are positioned. Everyone who cares about this story is watching the same patch of sky, waiting for the object to reappear. But there's a darkness around this story that hasn't lifted. A sense that something isn't being said. That information exists that we're not being given. That decisions have been made about what can be shared and what must remain hidden. Maybe that darkness is just the conspiracy-minded interpretation of normal bureaucratic delay. Space agencies are slow organizations. Data takes time to process. Interagency coordination is complicated. The silence isn't sinister, just procedural. Or maybe it's real. Maybe there's genuine concern among people who have access to full data about what they've observed. Maybe the decision to withhold certain images or analyses or measurements isn't about bureaucracy, but about managing revelation of something genuinely unprecedented. The challenge is that we can't tell the difference. Normal delay looks identical to deliberate withholding. Procedural slowness is indistinguishable from strategic information management. The absence of evidence isn't evidence of anything except absence. So we wait in darkness, not knowing what we're waiting for. Not knowing if the emergence in December will clarify everything or just deepen the mystery. What we do know is that this moment right now, these weeks in November, the countdown to December, represents something significant in human history. Regardless of what we ultimately discover, we're finally confronting the possibility that we might not be alone. Not as abstract thought experiment, but as practical question requiring immediate attention. For the first time, we have an object from another star system that might be more than just natural debris. An object that might have been sent deliberately. An object that might be observing us or checking on something in our solar system or preparing for something we don't yet understand. And we're wrestling with what that means. How to respond. What protocols to follow. Who speaks for humanity when contact scenarios emerge from theoretical planning into practical necessity. We're unprepared. Organizationally, philosophically, psychologically, we don't have consensus on fundamental questions. We don't have international agreement on how to proceed. We're fragmented, confused, reaching for frameworks that don't exist yet. But we're trying, and that might be enough. December will bring light. One way or another, the trajectory will be measured. The data will exist. The orbit will be calculated with precision that leaves no room for ambiguity. Either 3I Atlas is still leaving, continuing its journey back into interstellar space, becoming one more data point in our growing catalog of cosmic visitors, or it has stayed, captured itself into orbit through means we haven't observed but can infer from the mathematics of its path. If it's leaving, then this entire story becomes a case study, a lesson in how uncertainty and information gaps breed speculation, how pattern recognition can lead us astray, how the absence of explanation creates space for increasingly elaborate theories. We'll look back and laugh, perhaps uncomfortably, at how quickly we convinced ourselves that a natural comet might be something more. We'll recognize the cognitive biases at play, the tendency to see intention where only physics exists, to find meaning in coincidence, to construct narratives that feel more satisfying than random chance. But we'll also remember that the questions were legitimate, that the anomalies, while ultimately explainable through natural processes, were unusual enough to warrant careful examination. That taking the possibility seriously wasn't irrational given the data available, and we'll have learned something about ourselves, about how we respond to potential contact scenarios, about the gaps in our preparedness, about the need for better protocols and clearer communication, and more transparent information sharing when dealing with discoveries that could reshape human understanding of our cosmic context. That would be the optimistic outcome, the learning experience, the near miss that teaches us important lessons before we face a situation where the stakes are higher and the evidence is less ambiguous. But if 3I Atlas has stayed, then December becomes the dividing line, before and after, the moment when everything changed, not immediately, not dramatically. There won't be invasion fleets or first contact protocols or dramatic announcements that reshape civilization overnight. Change will be gradual, unfolding over weeks and months as we study the object, try to understand its purpose, attempt communication, watch for any indication of what it intends to do next. The darkness won't lift all at once. We'll still be working with incomplete information, making decisions based on insufficient data, fumbling toward understanding without clear roadmap. But we'll know something fundamental has shifted. We'll know that we're no longer alone in the solar system, that something from beyond is here, observing or waiting or preparing for something we can't yet predict. And that knowledge, that certainty that we share space with intelligence we didn't create, will gradually permeate every aspect of how we think about ourselves and our future. Chapter 26. The Signal Protocol. Let's talk about what happens if we detect a signal, not speculate about whether 3I Atlas is transmitting. That will be determined by radio telescopes pointed at it in December, but discuss the actual protocols that exist for how humanity responds if we receive communication from extraterrestrial intelligence. The SETI Post-Detection Protocol, established in 1989 and revised in 2010, outlines a series of steps that should be followed after confirmation of a genuine signal. Step 1. Verification. Independent confirmation from at least one other facility. No public announcement until multiple observers have detected the signal and verified it isn't terrestrial interference, equipment malfunction, or natural phenomena. This step could take days or weeks, depending on signal strength and availability of telescopes. False positives have occurred throughout SETI history, exciting detections that turned out to be satellites, terrestrial broadcasts, equipment glitches. Caution is warranted. Step 2. Notification. Once verified, the discoverer should notify the International Astronomical Union Central Bureau for Astronomical Telegrams. The Secretary General of the United Nations should also be informed. National authorities in the discovering country would be notified through established channels. This sounds orderly. In practice, the notification process would likely be chaotic. Information would leak before official announcements. Social media would spread the news. Competing claims about who detected what first would create confusion. Step 3. Public announcement. The discoverer should make the signal data available to the international scientific community for independent analysis. Public announcement should happen only after verification is complete, but should not be unnecessarily delayed. There's tension here between caution and transparency. How long is not unnecessarily delayed? Hours? Days? Who decides when sufficient verification has occurred? Step 4. Response decision. The protocol states clearly, no response should be sent until appropriate international consultations have taken place. This is the critical provision, the one that recognizes responding to extraterrestrial intelligence isn't just a scientific decision, but a political one, with implications for all humanity. But the protocol doesn't specify what appropriate international consultations means. Which bodies need to be consulted? What level of consensus is required? How long should consultations take before response is sent? And critically, is the protocol binding? Can it be enforced? What happens if one nation or organization decides to respond without waiting for international consensus? The United Nations Office for Outer Space Affairs, UNOSA, exists and could theoretically coordinate international response, but it has limited authority and no enforcement mechanism. If a government or private organization decided to transmit toward 3I Atlas without permission, there's no practical way to stop them. This is the scenario that keeps diplomatic and scientific communities awake at night, not the challenge of detecting extraterrestrial intelligence, but the impossibility of coordinating unified human response once detection occurs. Multiple actors with competing interests, national governments asserting sovereignty over communication decisions, private companies claiming first contact rights, religious organizations wanting theological input, scientific institutions demanding data access, public opinion demanding participation in decisions that affect entire species. How do you navigate that complexity when dealing with something unprecedented, time-sensitive, and potentially civilization-altering? You probably can't. Not perfectly. You muddle through. You convene emergency sessions and issue position papers and create ad hoc frameworks that address immediate questions while leaving larger governance structures to be worked out later. And if 3I Atlas is transmitting, if we detect a signal in December, that's exactly what we'll do. Muddle through, react to events rather than following carefully prepared plans, make decisions under pressure with incomplete information and insufficient consensus. It won't be elegant, it won't be efficient, but it will be human. Chapter 27. The waiting. There's a peculiar quality to these final weeks before December emergence. A suspended feeling, like holding your breath underwater, waiting to surface. Everyone following this story knows the timeline. We know when the object should become visible again. We know roughly what we'll be looking for: orbital elements, trajectory changes, any indication of non-gravitational acceleration or maneuvers. But knowing what questions will be answered doesn't make the waiting easier. If anything, it makes it harder, because we can see the finish line. We know resolution is coming, but we're stuck in this liminal space where nothing can be done except wait. The astronomical community is running final checks on equipment, testing observation protocols, coordinating timing across telescopes, making sure that when the moment comes, they're ready to collect the data that will either confirm or refute months of speculation. The amateur observers are doing the same, checking alignment, calibrating instruments, preparing data processing pipelines, ready to contribute to the largest coordinated observation campaign in the history of citizen science. Government officials are presumably doing something similar, though we don't see that activity. Behind closed doors, agencies are reviewing protocols, gaming out scenarios, preparing statements for various possible outcomes. And the rest of us, those who've been following the story but don't have telescopes or official roles, we're just watching, reading the latest updates, checking forums and social media for new analysis, waiting to see what December brings. There's a community that's formed around this story, people from different countries, different backgrounds, different perspectives, all focused on the same question: what is 3I Atlas and why is it here? Some are convinced it's artificial. They've examined the data, done the calculations, concluded that the probability of natural explanation is too low to accept. They're waiting for December to prove them right. Others are equally convinced it's natural. They've looked at the same data and seen normal cometary behavior with some unusual but explainable features. They're waiting for December to demonstrate that Occam's razor was correct. All along, the simplest explanation was the right one. And many, perhaps most, are genuinely uncertain, suspended between possibilities, aware that evidence exists, supporting both interpretations, waiting to see which way the data tips. Once we have post-perihelion observations, what unites all these perspectives is the recognition that we're living through something potentially significant, that this moment, regardless of outcome, represents a turning point in how seriously we take the possibility of extraterrestrial intelligence operating in our solar system. Before 3I Atlas, the conversation about alien visitors was largely theoretical. Fun to think about, interesting to speculate on, but not something requiring immediate practical attention. Now it's different. Now we have an object that demands to be taken seriously, that has enough anomalous features to justify careful investigation. That might be exactly what it appears to be, a comet, or might be something unprecedented requiring fundamental reconsideration of our cosmic solitude. The waiting is productive in its own way. It's giving us time to think through implications, to consider how we'll respond to various outcomes, to mentally prepare for revelation that might challenge comfortable assumptions. Because even if 3I Atlas turns out to be entirely natural, we now know that we're not prepared for the alternative. We know that our detection capabilities are improving rapidly, that the Vera Rubin Observatory will find more interstellar objects every year, that sooner or later we're going to encounter something that doesn't fit natural explanations. And when that happens, when we face unambiguous evidence of extraterrestrial technology, we'll need frameworks that don't currently exist, protocols that haven't been written, international cooperation that hasn't been established. December is practice. Whether 3I Atlas is artificial or not, we're learning what it feels like to confront the question seriously. We're identifying gaps in our preparedness. We're having conversations that need to happen before the stakes get higher. So the waiting serves a purpose. It's not just empty time. It's preparation, individual and collective, getting ready for whatever comes next. Chapter 28. The Mars Revelation. There's one piece of information that emerged quietly in mid-November, buried in a technical paper from European researchers analyzing Mars orbital data. The paper, published in a specialist journal with limited circulation, discussed thermal anomalies in the Terra Meridiani region, the kind of dry technical analysis that normally wouldn't attract attention outside narrow academic circles. But embedded in the appendix was something interesting. A table showing temperature variations at the sites where those controversial vertical structures are located, measured over time, tracked across Martian seasons. The structures are warmer than surrounding terrain. Not dramatically, we're talking about a few degrees Kelvin difference, but consistently warmer, through Martian winter and summer, day and night. Across multiple years of observation, the paper's authors suggested this might indicate unusual mineral composition. Certain rocks absorb and retain heat differently than others. Iron-rich formations, for instance, can stay warmer longer after sunset than silicate rocks. But there's a problem with that explanation. The heat signature doesn't follow the expected pattern for passive thermal retention. It's too constant, too stable, as if there's an internal heat source, maintaining temperature rather than just residual warmth from solar heating. The paper acknowledged this anomaly, but didn't press the point, suggested that more study is needed, called for additional observations. Standard academic caution when dealing with results that don't fit established models. But if you read between the lines, if you understand the implications of consistent internal heat in structures that should be cold rock, you start to see why this paper might be significant. Things that generate their own heat are either geologically active or technologically powered. Mars doesn't have significant geological activity, no plate tectonics, no volcanic system that could explain localized heat generation in Terra Meridiani specifically, which leaves technology. If the structures are artificial, if they're not natural geological formations but constructed installations, then internal heat makes sense. Power generation, life support systems, equipment operation, all would produce waste heat that would manifest as slightly elevated temperature compared to surrounding inert rock. The paper didn't say this explicitly, couldn't, without evidence strong enough to support such an extraordinary claim. But the data is there, published, available for anyone who looks, and it connects directly to the 3I Atlas timeline. The thermal observations in the paper extend through September 2025. The October 3rd flyby isn't included because data from that period hasn't been fully processed yet. But the September measurements showed temperature increase, slight but measurable, as if something in those structures became more active as 3I Atlas approached, like a system powering up, preparing for arrival, anticipating the close approach, and adjusting operational state accordingly. This is, again, interpretation layered onto data that admits multiple explanations. The temperature increase could be seasonal, could be measurement error, could be unrelated to 3i Atlas entirely, but the timing is notable. And the fact that this paper appeared in November, just before December emergence, suggests someone wanted this information available before the next round of observations. Before whatever happens next changes the context for interpreting thermal data from Mars. Chapter 29. The human element. Let's talk about the people behind this story. Because while we've been focused on objects and orbits and data and speculation, there are individual human beings whose lives have been shaped by 3i Atlas in ways that deserve recognition. Avi Loeb, obviously. The Harvard astrophysicist whose willingness to consider technological explanations has made him controversial within his own community. He's been criticized, mocked, accused of attention-seeking and sensationalism. His reputation has taken hits that might affect his career and legacy, but he's also been vindicated in some ways. Not necessarily proven correct about 3i Atlas being artificial, that determination hasn't been made, but proven correct that these questions deserve serious investigation. That dismissing possibilities out of hand because they seem unlikely is not good science. That anomalies should be examined carefully rather than explained away hastily. Loeb has taken professional risks to push this conversation forward. He's written papers knowing they'll be rejected by mainstream journals. He's given interviews knowing he'll be criticized. He's maintained his position despite significant pressure to step back and stop being so publicly speculative about extraterrestrial technology. That takes courage. It takes conviction that truth-seeking is more important than reputation management. And regardless of what 3i Atlas ultimately turns out to be, Loeb's willingness to ask uncomfortable questions has advanced the discourse in valuable ways. Then there are the amateur astronomers. People like Dobsonian Power and dozens of others who've spent their own time and resources trying to observe and analyze 3i Atlas. They've dealt with equipment limitations, atmospheric conditions, the challenge of tracking a fast-moving object across the sky. They've shared their data openly, posted their images, engaged in good faith discussions about interpretation and methodology, accepted criticism when their processing techniques were questioned, acknowledged uncertainty when they couldn't be sure what they were seeing. This is citizen science at its best. Non-professionals contributing meaningfully to understanding while maintaining appropriate epistemic humility about the limits of their observations. And there are the institutional scientists, the ones working within NASA, ESA, and other space agencies who are genuinely trying to understand 3i Atlas using proper scientific methods, who are analyzing data carefully, who are withholding conclusions until evidence is sufficient, who are frustrated by both premature speculation and unnecessary secrecy. They're caught in the middle, accused of cover-up when they urge caution, criticized for not being more forthcoming with preliminary data, pressured from multiple directions by people who want different things from the scientific process. Most of them are doing their best under difficult circumstances, trying to balance transparency with rigor, public interest with scientific accuracy, the desire to share discoveries quickly with the need to verify results thoroughly. They don't get enough credit for that. We focus on the conspiracy theories and the missing data and the institutional failures, but there are many individuals working very hard to do good science under unprecedented scrutiny. And finally, there's everyone who's been following this story. The millions of people worldwide who've read articles, watched videos, discussed possibilities with friends and family, who've experienced the strange mix of excitement and anxiety that comes from confronting the possibility that we might not be alone. This story has touched something deep in human consciousness, the old questions about our place in the cosmos, whether we're unique or typical, whether intelligence is rare or common, whether the universe is full of life, or we're the only ones looking up at the stars wondering. 3i Atlas, whatever it is, has made those questions feel immediate and real in ways they never have before. It's transformed speculation from abstract philosophy to practical concern requiring attention, and that's valuable regardless of outcome. Because we need to be thinking about these questions. We need to be preparing for possible contact scenarios. We need to be having conversations about how we want to interact with potential extraterrestrial intelligence and what values we want to represent when we do. December will affect all these people differently. Loeb will be either vindicated or further marginalized, depending on the trajectory data. Amateur astronomers will continue observing regardless, adding to the long-term record of the object's behavior. Institutional scientists will analyze whatever data emerges and publish their findings in peer-reviewed journals, and the rest of us will watch and wonder and wait to see what comes next. Chapter 30. The Threshold. We're at the threshold now, days away from early December, days away from knowing the astronomical infrastructure is ready. The observation protocols are in place. The data processing pipelines are tested and prepared. When 3I Atlas emerges from solar conjunction, we'll be watching with more concentrated attention than has ever been directed at a single object in the history of astronomy. Multiple telescopes in coordinated observation, amateur and professional, ground-based and space-based, optical, infrared, radio, every available instrument pointed toward one patch of sky, waiting for the interstellar visitor to reappear. The data will be decisive, not subject to interpretation or debate. The orbit either is or isn't bound. The trajectory either has or hasn't changed. Mathematics doesn't admit ambiguity at this level of measurement precision. If 3I Atlas is still leaving, if the eccentricity remains above 1, and the object continues on its hyperbolic escape trajectory, then we'll know by December 6th or 7th. The orbital elements will be calculated from multiple observations. The conclusion will be clear, and this entire story becomes a fascinating episode in the history of astronomy, a case study in how uncertainty breeds speculation, a reminder that not every anomaly has extraordinary explanation, a data point in our growing understanding of interstellar objects and how they behave when passing through our solar system. We'll have learned valuable lessons about observation protocols, about data sharing and transparency, about the importance of clear communication during periods of scientific uncertainty, about the gaps in our preparedness for potential contact scenarios. Those lessons will be useful when the next interstellar visitor arrives, and the next after that, because they will keep coming. Ruben will find them regularly. We'll have opportunities to study dozens of these objects over the coming decades, and eventually, statistically, one of them will be unambiguously artificial, will demonstrate capabilities that can't be explained through natural processes, will force us to confront the reality of extraterrestrial technology operating in our solar system. When that happens, we'll be better prepared because of what we learned from 3I Atlas. We'll have frameworks in place, protocols established, international cooperation developed, the experience of taking the question seriously without descending into panic or denial. That's the optimistic interpretation of a negative result. That even if 3I Atlas is natural, the episode will have served valuable purpose in preparing us for eventual contact. But there's the other possibility, the one that has been lurking throughout this entire narrative. The possibility that we don't get to treat this as a learning experience. That December doesn't let us return to comfortable assumptions about our cosmic solitude. If 3I Atlas has captured into orbit, if the trajectory calculations show eccentricity below 1, and the object has deliberately braked to stay in our solar system, then everything changes. Not immediately, not all at once, but fundamentally and irreversibly. We'll know, with mathematical certainty, that something from beyond has chosen to remain, that whatever sent it intended for it to stay, that monitoring or preparation or investigation of some kind is ongoing, and we'll have to decide how to respond, what to do with that knowledge, how to reorganize our understanding of ourselves and our future to accommodate the reality of non-human intelligence sharing our solar system. There will be fear. Understandably, the unknown is frightening, especially when it involves capabilities exceeding our own and intentions we can't determine. There will be excitement, the opportunity to learn from intelligence more advanced than ours, the possibility of accessing knowledge and technology that could solve problems we've struggled with for centuries. There will be confusion, disagreement about interpretation, competing theories about purpose and origin. Fractured response, as different groups pursue different goals based on different assumptions. But there will also be something else, something harder to name, but potentially more important than fear or excitement or confusion. Recognition. Recognition that we're part of something larger, that the cosmos isn't empty, that intelligence, consciousness, the ability to understand and manipulate the physical world, these aren't unique human properties, but features of the universe itself, expressing in multiple locations throughout space and time. That recognition won't answer all questions, won't solve all problems, won't make the challenges ahead any easier, but it will shift perspective, change how we think about ourselves and our relationship to everything beyond Earth, give us context for human existence that we've lacked since we first looked up at the stars and wondered what was out there. December brings that moment, that threshold, that pivot point where wondering becomes knowing and speculation becomes certainty. The data will tell us which direction we're going, whether this is the end of one story or the beginning of something much larger. Either way, we'll know soon. The countdown is nearly over. Epilogue. The view from here. There's a photograph I keep returning to. Not the Perseverance image from Mars, though that's significant. Not the ESA fuzzy dots or the Hubble observations or any of the processed data released by institutions. It's an amateur capture from early October, a backyard telescope in Australia. Long exposure showing 3I Atlas as a small, slightly elongated smudge moving against the background stars. Nothing dramatic, nothing that reveals secrets or proves theories. Just a simple image showing that the object exists, that it's real, that it's out there moving through space regardless of what we think about it or what we hope it might be. That photograph represents something important about this entire story. It shows that some questions aren't about institutional authority or official announcements or who has access to the best equipment. Some questions are about looking up and paying attention and acknowledging that the universe is under no obligation to conform to our expectations. 3I Atlas exists. It came from somewhere else. It's moving through our solar system right now, following a path determined by gravity and possibly by intention we can't yet confirm. That's verifiable, observable, true regardless of interpretation or speculation or theory. What it means, what it tells us about our place in the cosmos, about whether we're alone, about what intelligence does when it spans the distances between stars. Those questions remain open. December will close some of them, will give us data that constrains possibility space and eliminates some hypotheses while supporting others. But December won't answer everything, can't answer everything, because even if we determine that 3I Atlas is technological, we won't immediately understand its purpose, or predict its behavior, or know what its presence means for human future. We'll just know that it's there, that we share space with intelligence we didn't create, that the old assumptions about cosmic isolation need revision, and then the real work begins. Not the speculation and analysis and pattern recognition we've been doing for months, but the actual engagement, the communication attempts, the careful observation, the slow process of understanding something fundamentally different from ourselves. That work will take time, years, decades, possibly. It won't happen through dramatic revelations or sudden breakthroughs. It will happen through patient attention, repeated observation, gradual accumulation of data points that eventually coalesce into understanding. This is how first contact actually looks, if it happens at all. Not the Hollywood version, with spacecraft landing on the White House lawn and representatives stepping out to address humanity, but slow recognition, increasing certainty, careful attempts at engagement with something that doesn't share our biology or our culture or our communication frameworks. It's messy, it's uncertain, it's frustrating for those who want clear answers immediately, but it's also real. It's happening now, potentially, and that makes it more significant than any fictional scenario, no matter how dramatically satisfying those scenarios might be. So we watch, we measure, we calculate, we attempt to understand using the tools we have while acknowledging their limitations, and we wait for December, because December brings the data, the trajectory calculations, the orbital elements that will tell us whether 3I Atlas stayed or left. Whether this story continues or concludes, whether we're alone or accompanied, the view from here, late November 2025, standing on Earth, looking out at the solar system that might contain intelligence beyond our own, is strange and uncertain and pregnant with possibility. We don't know what comes next, can't predict how this ends, don't have frameworks adequate for the scenarios we're considering, but we're looking, we're paying attention, we're ready to adjust our understanding when new data arrives. And that might be the most human thing of all, the willingness to confront uncertainty without retreating into comfortable denial, the curiosity that drives us to keep watching even when answers remain elusive, the recognition that some questions are worth asking even when we're not sure we want to know the answers. 3i Atlas is still out there, moving through space, following its trajectory toward whatever comes next. We're still here, watching, wondering, waiting, and in a few days, we'll know. The countdown ends in December,